The universe is a brain, and you are one of its thoughts. Not a metaphor, not poetry. A hypothesis backed by structure, by scale, by numbers so precise they feel like a message left behind. The human brain contains roughly 86 billion neurons, woven into 100 trillion synaptic connections that somehow produce the sensation of you. The observable universe contains 2 trillion galaxies, strung together across 93 billion light-years by invisible filaments of dark matter and gas. And when you place an image of your brain's neural network next to an image of the cosmic web, you cannot tell them apart. The resemblance is not vague, it is not approximate. It is pixel for pixel, structure for structure identical, as if the universe photocopied its own design and pressed it into the matter inside your skull. Scientists call this a coincidence. Philosophers are not so sure. Because the deeper we dig into the laws that govern reality, the stranger the picture becomes. The forces that hold atoms together, the constants that allow stars to burn and chemistry to exist, all of them sit balanced on a knife's edge, so impossibly narrow that even a fraction of a % shift in any direction would erase complexity from existence entirely. The universe is not just capable of producing consciousness, it is fine-tuned for it, as if awareness was the goal from the beginning. So what if consciousness is not something that happened to emerge in biological meat after billions of years of evolution? What if it was always here, woven into the fabric of space itself, waiting for matter to organize into shapes complex enough to feel it? And what if those 2 trillion galaxies are not dead islands of gas and starlight, but neurons firing in a mind too vast for us to comprehend? This is that story. Welcome to Magnetic Space. If you're new here, please subscribe. We make these documentaries every day, and honestly, we'd love to have you along for the ride. Before we begin, tell us in the comments where you're watching from and what time it is there. Now settle in. This is going to be a good one. There is a photograph that has been circulating through academic conferences and late-night internet rabbit holes for the better part of 2 decades. On the left side of the image sits a thin slice of mouse brain tissue, magnified several thousand times, showing a tangle of neurons branching and connecting in an intricate web of biological wiring. On the right side sits a computer simulation of the large-scale structure of the universe, a map of how galaxies and galaxy clusters are distributed across billions of light-years of space. The 2 images are almost identical, not similar, not kind of alike in a way that makes you squint and tilt your head. Identical, same branching structure, same dense nodes connected by thin filaments, same vast empty regions between the clusters. If you removed the labels, you would not be able to tell which one was which, and that should bother you, because the scales involved are not just different. They are separated by a factor so absurd that the human brain, the very organ we are talking about, cannot properly visualize it. A neuron is measured in micrometers. A galaxy is measured in light years. The distance between those 2 units is roughly 40 orders of magnitude. That is not a typo. 40. You could fit a trillion neurons inside the space occupied by a single galactic supercluster. And yet when you map them, when you trace the connections and plot the densities and render the structures in 3 dimensions, they look like twins. So here is the question that refuses to go away, no matter how many times scientists try to dismiss it as coincidence. Why? Why does the most complex object we have ever discovered inside our own skulls bear such an uncanny resemblance to the largest structure we have ever mapped outside of it? And before you answer, before you reach for the easy explanation that all networks look alike, or that this is just a quirk of mathematics, You need to understand exactly what we are comparing, because the similarities run deeper than a single photograph. Let's start with what is inside your head right now. The human brain contains roughly 86 billion neurons. That number used to be 100 billion. You will still see 100 billion in older textbooks, and in approximately 90% of the articles written by people who did not bother to check the updated research. The revised figure comes from a Brazilian neuroscientist named Susana Herculano Rosel, who in 2009 developed a method to actually count brain cells by dissolving the tissue into a uniform suspension and tallying the nuclei under a microscope. Turns out we had been rounding up for decades based on estimates that were, to be polite, optimistic. 86 billion is still a stupidly large number. If you tried to count every neuron in your brain at a rate of 1 per second, it would take you 2,700 years. You would outlive empires. And those 86 billion neurons are only half the story. For every neuron, there is roughly one other cell. Glial cells, support cells, the infrastructure that keeps the whole system from collapsing. And each neuron is not sitting in isolation. Each one connects to thousands of others through junctions called synapses. The best current estimates put the total number of synapses in the human brain at around 100 trillion. 100 trillion tiny gaps where chemical signals jump from one cell to another, where information is filtered, amplified, suppressed, rerouted. Every thought you have ever had, every memory you have ever stored, every decision you have ever made, every emotion that has ever swept through you without warning, all of it is the result of electrical impulses racing across this impossibly dense network of connections. Your brain is not a computer in the way most people think of computers. It is not running software. It is not retrieving files from a hard drive. It is a living, continuously reconfiguring web of signals where the structure itself is the information. The pattern of connections is the code. Change the wiring and you change the person. The architecture is not random. Neurons are organized into circuits. Small local loops that handle specific tasks. Those circuits group into larger networks. Those networks link into even larger systems. Vision, hearing, movement, language, emotion, all of them running simultaneously, all of them influencing each other through layers of feedback and crosstalk that neuroscientists are still trying to map. The field is called connectomics, and it is one of the most ambitious projects in modern biology. The goal is to trace every neuron and every synapse in a complete brain and build a wiring diagram of consciousness itself. So far, we have managed to map the connectome of exactly one organism, a roundworm called C. elegans. It has 302 neurons. Mapping those 302 neurons and their 7,000 synapses took more than a decade. The human brain has 86 billion neurons and 100 trillion synapses. If you scale up the effort linearly, which is generous because the complexity grows faster than the cell count, a complete human connectome would take somewhere in the neighborhood of several million years. We are not close. But even the partial maps we do have reveal something striking. The brain is not a tangle. It is not a random mess of wiring. It is organized into hubs and modules, high-traffic nodes where information converges from multiple regions and gets redistributed. The structure follows patterns that show up in social networks, power grids, airline routes, the internet. It is what mathematicians call a small world network, high clustering, short path lengths. Any neuron can reach any other neuron in just a few steps, even though the total number of connections is nowhere near the theoretical maximum. Efficiency and redundancy built into the same system. And here is the part that should make you pause. That same architecture, that same combination of clustering and short paths and hub and spoke connectivity shows up again when you zoom out by 40 orders of magnitude and look at the universe. The cosmos is not uniform. If you could somehow step outside the universe and look at it from a distance, you would not see a smooth cloud of stars and gas. You would see a web. Astronomers call it the cosmic web, and it is the largest known structure in existence. Galaxies are not scattered randomly through space. They cluster together in groups. Those groups link into superclusters. And between the clusters, stretching across hundreds of millions of light years, are filaments, long thin threads of galaxies connected like beads on a string. Between the filaments sit voids, vast empty regions where almost nothing exists. No galaxies, no gas, no stars, just darkness. The filaments, the clusters and the voids together form a network that looks, when you map it, almost biological, like capillaries in tissue, like roots spreading underground, like neurons in a brain. The comparison is not new. Astronomers noticed it as soon as they started building three-dimensional maps of galaxy distributions back in the 1980s. But for a long time, it was treated as a curiosity, a neat coincidence, something you mention at the end of a conference talk to get a laugh. Then, in 2020, an astrophysicist named Franco Vazza at the University of Bologna and a neurosurgeon named Alberto Folletti published a paper that took the comparison seriously. They ran a quantitative analysis comparing the structure of the cosmic web to the structure of the human brain. They calculated the number of nodes, the number of connections, the distribution of clustering, the average path length. They even measured something called spectral density, which describes how information or matter is distributed across different scales. The results were uncomfortable. The two systems were not just similar. By several measures, they were statistically indistinguishable. Let's talk about the numbers, because this is where things get strange. The human brain has 86 billion neurons. The observable universe, according to the best estimates from deep field surveys and statistical modeling, contains somewhere between 100 billion and 2 trillion galaxies, depending on how you count and what you are willing to call a galaxy. 2 trillion is the high-end estimate published in 2016 based on Hubble data and a lot of extrapolation. 100 billion is a more conservative figure that only counts galaxies bright enough and large enough to show up clearly in surveys. Either way, the order of magnitude is the same. Billions to trillions, brain cells to galaxies. And just like neurons connect through synapses, galaxies connect through filaments, long bridges of dark matter and gas that funnel material between clusters. The filaments are not empty. They contain stars, gas clouds, wandering galaxies. They are the highways of the universe. Matter flows along them. Galaxies collide and merge where filaments intersect. The densest nodes in the cosmic web, the places where multiple filaments meet, are the largest galaxy clusters we know. Structures like the Coma cluster or the Virgo supercluster. Thousands of galaxies bound together by gravity, sitting at the intersection of cosmic highways like a city built at the confluence of rivers. The voids between the filaments are not quite empty, but they are close. Surveys have found a few dim dwarf galaxies drifting through the voids, but the density of matter there is less than 10% of the cosmic average. In brain terms, the voids are like the gaps between neurons, dead space, room for signals to travel without interference. And when you measure the size distribution of voids in the cosmic web and compare it to the size distribution of gaps in neural networks, the curves match. Vazza and Folletti calculated something called the power spectrum for both systems. The power spectrum tells you how much structure exists at each scale. In a perfectly random distribution, the power spectrum is flat. All scales contribute equally. In a highly ordered system like a crystal, the power spectrum has sharp peaks at specific scales. In a complex network, the power spectrum follows a power law, a straight line on a log-log plot, which means structure exists at all scales, but larger structures are rarer. The brain follows a power law, the cosmic web follows a power law, and the slopes are nearly identical. That is not something you expect from two systems that have nothing in common except the fact that they are both networks. Power laws show up in a lot of places: earthquake magnitudes, city sizes, word frequencies, income distributions. But the specific shape of the curve, the exponent, varies depending on the underlying physics. For the brain and the universe to have matching exponents suggests they are governed by similar rules. Not the same rules, similar ones. Rules about how matter and energy and information organize themselves when they are allowed to evolve freely over long timescales. Another similarity: both systems are mostly empty. The human brain is roughly 77% water by weight. Neurons make up only a small fraction of the total volume. The rest is fluid, support cells, blood vessels, connective tissue. The space between neurons is critical. It is where chemical signals diffuse, where waste products are cleared, where the electrical insulation that allows neurons to fire quickly is maintained. Remove the empty space and the brain stops working. The universe is even more extreme. Normal matter, the atoms that make up stars and planets and people, accounts for less than 5% of the total mass-energy content of the cosmos. Dark matter makes up about 27%. Dark energy makes up the rest. Roughly 68% of the universe is empty space filled with a mysterious, repulsive force that is pushing everything apart. And even within the 5% that is normal matter, most of it is empty. A hydrogen atom is 99.9999996% empty space. The nucleus is a tiny dot. The electron cloud is a probability smear. If you removed all the empty space from every atom in every human body on Earth, the entire human species would fit inside a sugar cube. We are mostly nothing. The universe is mostly nothing. And somehow, in both cases, the nothing is what makes the structure work. The resemblance extends to how these networks grow. Neurons do not start out fully connected. A newborn human brain has far more neurons than an adult brain. Somewhere around 86 billion at birth, same as adulthood, but with twice as many synapses. Early childhood is a period of explosive synapse formation, followed by aggressive pruning. Connections that get used strengthen. Connections that sit idle get deleted. By adolescence, roughly half of the original synapses are gone. What remains is a leaner, faster, more efficient network shaped by experience. The process is called synaptic pruning, and it is one of the reasons human brains are so adaptable. We are not born with fixed wiring. We are born with too much wiring, and we spend the first 20 years of life cutting it down to what we actually need. The cosmic web follows a similar trajectory. In the early universe, matter was distributed almost uniformly. Tiny fluctuations in density, deviations of 1 part in 100,000, were imprinted during the first fraction of a second after the Big Bang. Over time, gravity amplified those fluctuations. Denser regions pulled in more matter. Less dense regions emptied out. The result was a runaway process where the rich got richer and the poor got poorer. Dense regions collapsed into galaxies. The space between them stretched into voids. Filaments formed where matter streamed from voids into clusters. By the time the universe was a few billion years old, the cosmic web was fully formed. And just like the brain, the universe did not arrive at this structure through top-down design. There was no blueprint, no plan, just local rules, gravity pulls, dark energy pushes, matter clumps. And from those simple rules, applied over and over across billions of years and trillions of particles, a network emerged. There is a term in mathematics for patterns that repeat at different scales, fractals. The classic example is a coastline. Zoom in and it looks jagged. Zoom out and it still looks jagged. The shape is self-similar. The brain is not a perfect fractal, but it has fractal-like properties. The branching structure of a single neuron, dendrites splitting into finer and finer branches, mirrors the branching structure of neural circuits, which mirrors the branching structure of whole brain networks. The cosmic web is the same. A galaxy cluster looks like a scaled-up version of a galaxy group, which looks like a scaled-up version of a galaxy with its satellite dwarf galaxies, which looks like a scaled-up version of a solar system with its planets. Same pattern, different sizes. And this is the point where most scientists will stop you and say, all right, sure, they look alike, but so what? Networks are common. Scale-free distributions are common. Fractals are common. You are reading meaning into a coincidence. The brain and the universe are not the same kind of system. One is biological, one is cosmological, one runs on chemistry and electricity, one runs on gravity and dark matter. The fact that they both happen to form networks does not imply any deeper connection, and they are right, mostly. The resemblance does not prove anything. Looking similar is not the same as being similar. But here is the thing. Coincidences are supposed to be rare, and the list of similarities between the brain and the universe is not short. It keeps growing. The number of nodes is comparable. The connectivity per node is comparable. The clustering is comparable. The power spectrum is comparable. The voids are comparable. The growth process is comparable. At some point, you have to ask whether calling it a coincidence is just a way to avoid asking uncomfortable questions. Because if the universe does resemble a brain, even structurally, even by accident, it raises a question that science has spent the last few centuries trying to ignore. What if the resemblance is not an accident? What if the universe is not just structured like a network? What if it is a network? What if the reason the cosmos looks like a thinking system is because, in some sense we do not yet understand, it is one, not thinking in the way humans think, not conscious in the way we are conscious, but doing something, processing something, running some vast computation that we, as tiny subsystems embedded inside it, are not equipped to recognize from the inside. This is not a new idea. Philosophers have been playing with it for thousands of years, but for most of history, it was metaphor, poetry, a way to talk about the divine without invoking gods. Now, for the first time, we have data, we have maps, we have measurements, and the measurements are telling us that the metaphor might be uncomfortably close to accurate. The brain and the universe are not identical, but they are cousins, built by different rules, operating on different scales, made of different materials, but shaped by the same deeper logic. The logic of networks, the logic of emergence, the logic that says complexity does not come from complicated parts. It comes from simple parts connecting in the right way. And if that logic can take 86 billion neurons and turn them into a mind, what could it do with 2 trillion galaxies? That is the question we are about to chase. And the answer, if there is one, is going to require us to talk about fine-tuning, about constants and parameters, and the knife-edge balance of forces that allows anything to exist at all. Because if the universe really is structured to produce complexity, if it really is built to generate networks and information and perhaps something stranger, then the odds that it ended up this way by accident start looking very, very small. So the universe looks like a brain, and that should make us uncomfortable. But resemblance is cheap. Clouds look like faces sometimes, and nobody thinks the sky is trying to tell us something. Structure alone proves nothing. If you want to argue that the universe is not just shaped like a thinking system, but might actually be one, or at least built to produce one, you need more than a photograph. You need physics. You need numbers, and as it turns out, the numbers are worse than the photograph, far worse. Because when you start looking at the actual laws that govern how matter and energy behave in this universe, you find something that has been quietly driving physicists and philosophers to the edge of madness for the better part of a century. The laws are not just suitable for life, they are absurdly, unreasonably, almost offensively fine-tuned for it. Change any one of a dozen fundamental constants by a fraction of a percent, and the universe becomes a sterile void. No stars, no chemistry, no complexity, no anything. And the kicker is this: the range of values that allows for a universe capable of producing something as complicated as a brain, your brain, the one reading meaning into these words right now, is so narrow that if you were to throw a dart at the space of all possible universes, the odds of hitting one like ours would be smaller than guessing a single specific atom out of all the atoms in the observable cosmos. That is not an exaggeration. That is the math, and nobody knows why. Let's define terms, because fine-tuning is one of those phrases that gets thrown around until it loses meaning. In physics, fine-tuning refers to a situation where the parameters of a system must fall within an extremely narrow range to produce a specific outcome. The universe has a set of fundamental constants, numbers that show up in the equations governing everything from gravity to nuclear forces to the expansion of space itself. These constants are not derived from deeper principles, at least not ones we know. They are measured. We go out into the world, run experiments, and write down what we find. The gravitational constant, the speed of light, the mass of the electron, the strength of the electromagnetic force, the cosmological constant. Dozens of them, and as far as we can tell, there is no reason these numbers have to be what they are. The equations would work just fine if the constants were different. The math would not break. You would still have a universe. It just would not be this one. And in the vast majority of cases, it would not be a universe where anything interesting could happen. Stars would not form. Atoms would not hold together. Space itself might collapse or fly apart so fast that matter could never clump into structures. Fine-tuning is the observation that we live in one of the rare universes where the constants landed in the narrow sweet spot that allows complexity. And the question that refuses to go away is whether that was luck or something else. Start with the strong nuclear force. This is the force that holds protons and neutrons together inside atomic nuclei. Protons are positively charged. Positive charges repel. If the electromagnetic force were the only game in town, every nucleus heavier than hydrogen would fly apart. The strong force overpowers that repulsion, but only at extremely short distances. It is strong enough to bind protons and neutrons into stable clusters, but weak enough that the repulsion still matters. The balance is delicate. If the strong force were weaker by about 5%, deuterium, the simplest fusion product, would not be stable. Without deuterium, stars could not fuse hydrogen into helium. No helium means no carbon, no oxygen, no heavy elements. The periodic table stops at hydrogen. If the strong force were stronger by about 5% in the other direction, hydrogen itself would become too sticky. Protons would bind so easily that the early universe would have fused almost all of its hydrogen into helium within the first few minutes after the Big Bang. No hydrogen means no water, no organic chemistry, no long-lived stars like the Sun that burn steadily for billions of years. The window where you get both stable hydrogen and stable heavier elements is narrow. A few percent either way, and the universe is a dud. Then there is the weak nuclear force. This one governs radioactive decay and certain types of particle interactions. It is responsible for the process that allows protons to turn into neutrons and vice versa. In the early universe, that process determined how much hydrogen and helium ended up in the final mix. If the weak force were about 10 times weaker than it actually is, neutrons would have been much more common in the first few minutes after the Big Bang. More neutrons means more helium. Run the numbers and you end up with a universe where nearly all the hydrogen fuses into helium almost immediately. Again, no hydrogen, no stars like ours, no chemistry. If the weak force were much stronger, the opposite happens. Neutrons decay too quickly and you are left with almost pure hydrogen. That sounds fine until you realize that stars need helium and heavier elements to regulate their fusion processes. A pure hydrogen universe gives you stars that burn out fast and erratically. No stable stellar environments, no planets with billions of years of calm sunlight to let chemistry do its thing. Gravity is even worse. Gravity is the weakest of the 4 fundamental forces by an absurd margin. The gravitational attraction between 2 protons is about 10 to the 36th times weaker than the electromagnetic repulsion between them. 10 to the 36th. That ratio is not a typo, and it is not a rounded number. It is measured, and if that ratio were significantly smaller, if gravity were stronger relative to electromagnetism, stars would be smaller, hotter, and shorter-lived. A star the mass of the Sun in a universe with slightly stronger gravity would burn through its fuel in millions of years instead of billions. Not enough time for planets to cool, for oceans to form, for life to evolve past single cells, if it got started at all. If gravity were weaker, stars would be larger, cooler, and dimmer. Sounds nice until you realize that large, cool stars do not produce enough ultraviolet radiation to drive the chemical reactions that power early biology. They also do not explode as supernovae the way smaller stars do, which means they do not seed the interstellar medium with heavy elements. No supernovae, no carbon, no oxygen, no iron. The universe stays locked in hydrogen and helium forever. The cosmological constant is the one that makes physicists want to quit and become poets. The cosmological constant represents the energy density of empty space, what we now call dark energy. It is the thing that is causing the universe to expand faster over time. The measured value is absurdly small. In natural units, Planck units, the ones physicists use when they want to talk about the fundamental scales of reality, the cosmological constant comes out to about 10 to the negative 122. That is a decimal point followed by 121 zeros and then a 1. It is the smallest measured parameter in all of physics, and nobody knows why. Quantum field theory, the framework that describes particle physics, predicts that empty space should have energy, a lot of energy. When you add up all the contributions from virtual particles popping in and out of existence, you get a number for the cosmological constant that is about 10 to the 120 times bigger than what we actually observe. That is not a small discrepancy. That is the worst prediction in the history of science, off by 120 orders of magnitude. Theoretical physicists have been trying to explain this mismatch for decades, and they have made essentially no progress. But here is the kicker. If the cosmological constant were just slightly larger, even by a factor of 10, the universe would have expanded so fast in its early history that gravity would never have been able to pull matter together into galaxies and stars. Space would have stretched too quickly for structure to form. You would end up with a cold, dark, empty universe where hydrogen atoms drift alone forever, separated by distances that grow faster than light can cross them. If the cosmological constant were negative, the universe would have recollapsed into a big crunch within a few million years. Either way, no stars, no planets, no time for anything interesting to happen. Then there is the density parameter. In the first fraction of a second after the Big Bang, the universe was expanding and gravity was pulling back. The balance between the expansion rate and the density of matter determined whether the universe would expand forever, coast to a halt, or collapse. That balance is encoded in a number called omega. Omega equal to 1 means the universe is perfectly balanced, flat, right on the edge. Omega greater than 1 means too much matter, eventual collapse. Omega less than 1 means not enough matter, runaway expansion. The measured value of omega today is extremely close to 1. Close enough that in the early universe it must have been equal to 1 to within 1 part in 10 to the 15th, 1 part in a million billion. If omega had been even slightly higher at the beginning, the universe would have recollapsed before stars could form. If it had been slightly lower, matter would have spread out too quickly for gravity to build galaxies. The fact that omega started out so precisely tuned is one of the major puzzles of cosmology. Inflation, the theory that the universe underwent a brief period of exponential expansion in its first moments, was invented partly to explain why omega is so close to 1. Inflation stretches space flat, the way blowing up a balloon smooths out wrinkles. It works, sort of, but it does not explain why inflation happened or why it stopped at exactly the right moment. It just pushes the fine-tuning back one level. There is also the parameter called Q. Q measures the amplitude of the density fluctuations imprinted in the early universe, the tiny ripples that eventually grew into galaxies. The measured value of Q is about 10 to the negative 5, 1 part in 100,000. If Q were smaller, the fluctuations would have been too weak. Gravity would not have had enough to work with. The universe would have stayed smooth and featureless, no galaxies, no stars, just a thin uniform fog of hydrogen drifting forever. If Q were larger, the fluctuations would have been too strong. Matter would have clumped so aggressively that the universe would have been full of black holes from the start. No stable stars, no long-lived structures, just a chaotic mess of collapsing matter and radiation. The range where Q allows for the slow, steady formation of galaxies over billions of years is narrow. Change it by a factor of 10 in either direction, and you lose the universe as we know it. The Higgs field is another one. The Higgs field is what gives particles mass. The strength of the Higgs field is determined by something called the vacuum expectation value. That value is measured to be about 246 giga-electron volts. If it were much smaller, particles would have less mass. Electrons would be lighter, atoms would be larger, chemistry would not work the same way. If it were much larger, particles would be heavier, atoms would be smaller and less stable, and again chemistry breaks. A 2025 review estimated that the range of Higgs values consistent with anything resembling our universe is less than 1 part in 10 to the 16th, 1 part in 10,000 trillion. Step outside that range and you do not get minor changes. You get a universe where complex structures cannot form. Here is the part that keeps people awake. These constants are independent as far as we know. Changing one does not automatically adjust the others to compensate. The strong force has nothing to do with the cosmological constant. Gravity does not care about the Higgs field. Each parameter is a separate dial, and every single one of them has to be set correctly for the universe to produce stars, planets, and eventually life. The probability of all of them landing in the right range by chance is stupidly small. Some estimates put it at less than 1 part in 10 to the 100. Others go much higher, depending on how many parameters you include and how you measure the range. Either way, the number is small enough that calling it astronomical is an insult to astronomy. This is where the anthropic principle enters the conversation and immediately makes everything worse. The weak anthropic principle is the uncontroversial version. It says that we observe a universe capable of supporting life, because if the universe were not capable of supporting life, we would not be here to observe it. This is a selection effect. You do not wake up surprised that you are alive. You could not wake up dead. The weak anthropic principle is a tautology, but it is a useful one. It reminds us that the fact we exist does not require an explanation beyond the observation that non-existent beings do not make observations. The strong anthropic principle is the troublemaker. The strong version, depending on who you ask, says that the universe must have properties that allow life to develop at some point, because otherwise there would be no observers, and a universe without observers is somehow incomplete. This version edges uncomfortably close to teleology, the idea that the universe has a purpose. John Barrow and Frank Tipler, two physicists who wrote extensively about the anthropic principle in the 1980s, pushed this idea into strange territory. Tipler in particular argued that the existence of observers places constraints on the laws of physics, that the universe is in some sense required to produce consciousness. Most physicists treat the strong anthropic principle with suspicion because it smells like philosophy dressed up as science. It does not make predictions you can test. It does not tell you what experiments to run. It just sits there, offering a vague sense of purpose without specifying whose purpose or how it gets implemented. The fine-tuning problem splits the scientific community into camps, and the arguments get personal. One camp says fine-tuning is evidence of design, not necessarily a religious designer, though that interpretation is popular in certain circles, but some kind of intentionality behind the structure of physical law. The constants did not land in the right range by accident. They were set. By what? By whom? How? Nobody in this camp has a good answer, but they argue that the alternative, blind luck on a scale of 1 in 10 to the 100, is less plausible than admitting we do not understand why the universe is the way it is. The second camp invokes the multiverse. If there are countless universes, each with different values for the fundamental constants, then it is no surprise we find ourselves in one of the rare life-permitting ones. We could not find ourselves anywhere else. The multiverse does not require design. It just requires an enormous number of trials. Throw enough darts, and eventually one hits the bullseye. This explanation is popular in certain areas of theoretical physics, particularly among people working on string theory and eternal inflation, both of which predict a vast landscape of possible universes. The problem is that the multiverse is not testable. You cannot observe other universes. You cannot measure their constants. You cannot run experiments to confirm they exist. It is an explanation that solves the fine-tuning problem by making the problem unobservable, which some argue is not really solving it at all. The third camp is more cautious. They point out that the fine-tuning argument depends on assumptions we cannot verify. We assume the constants could have been different, but what if they could not? What if there is some deeper law, some theory we have not discovered yet, that fixes the constants at their observed values, the way the charge of the electron is fixed by quantum mechanics. If the constants are not free parameters, if they are determined by logic or symmetry or some principle we do not yet understand, then there is no fine-tuning. The universe is the only way it could be. This camp does not have an answer either, but they argue that jumping to design or multiverses before we understand the physics is premature. The fine-tuning might be real, or it might be an artifact of our ignorance. The Stanford Encyclopedia of Philosophy, which is about as neutral a referee as you can get in these fights, notes that fine-tuning arguments mix physical facts with interpretive claims. The constants are what they are. That part is not controversial. What you conclude from that fact depends on what you think counts as a life-permitting universe and how you measure the range of possible constants. Those choices are not given by physics, they are philosophical. Some apparent fine-tuning claims fall apart when you look closely at the assumptions, others hold up. The debate is not settled, and it probably will not be settled until we have a deeper theory that explains where the constants come from. A 2025 review from Cambridge describes the situation as extreme sensitivity. Very small changes in the constants produce dramatically different universes. That part is solid. The interpretation of what that sensitivity means is where people start shouting. Here is the uncomfortable part. If you take the fine-tuning at face value, if you accept that the universe really is balanced on a knife edge, then the question stops being whether the universe is designed and starts being what it is designed for. Because a universe fine-tuned for life is also a universe fine-tuned for complexity. And a universe fine-tuned for complexity is a universe fine-tuned for information processing. Stars are information processors. They take hydrogen, compress it, fuse it, and produce heavier elements and energy. That is computation in the thermodynamic sense. Planets are information processors. Weather patterns, ocean currents, geological cycles, all of them are systems that take in energy, rearrange matter, and output structure. Life is obviously an information processor. Evolution is an algorithm. DNA is code, brains are networks. If the constants were set to allow stars and chemistry, they were also set to allow something like thought. Not because thought is the goal, necessarily, but because thought is what you get when you build a universe capable of sustained complexity. You cannot have one without the other, and that brings us full circle to the question we started with. If the universe is structured like a brain and fine-tuned to produce brains, then maybe the resemblance is not a coincidence. Maybe structure and function are connected. Maybe the cosmos is not just capable of generating consciousness. Maybe consciousness is what the cosmos does. Not everywhere, not all at once, but in pockets, in systems like us. And if that is true, if consciousness is not an accident, but a natural outcome of the laws that govern everything, then the next question is whether consciousness is exclusive, whether it is something that only happens in biological brains, or whether it is something more fundamental, something that might, under the right conditions, exist at scales we have not seriously considered. Scales like galaxies, like galaxy clusters, like the universe itself. That is not a question physics can answer yet, but it is a question philosophers have been asking for a very long time, and it has a name. So we have a universe that looks like a brain and is tuned to produce brains. That is uncomfortable enough on its own. But the real problem starts when you try to explain what a brain actually does, not the mechanics. The mechanics are fine. Neurons fire, chemicals diffuse, electrical signals propagate. We can measure all of that. The problem is the other thing, the thing happening on top of the mechanics. The fact that it feels like something to be you. that there is an interior experience, a subjective sensation of existing, a continuous stream of awareness that has been running inside your skull for as long as you can remember and will keep running until the day it stops. Philosophers call this consciousness. Scientists call it the hard problem. And after thousands of years of thinking about it, we still do not have a good explanation for why it exists at all. Unless, and this is where things get very strange, it does not exist because of brains. What if consciousness is not something brains create? What if it is something they detect? What if the universe has been conscious the whole time and we have been looking in the wrong place? That idea has a name: Panpsychism. The view that consciousness is not an exclusive feature of complex nervous systems, but a fundamental property of reality itself, not just in humans, not just in animals, everywhere, in every particle, every atom, every rock, every star. The entire cosmos, soaked in some form of experience from the ground up. It sounds insane. It has sounded insane to most scientists for the better part of a century. But the number of very serious, very sober philosophers and physicists willing to entertain the idea has been growing quietly in the background. And the reason they are willing to entertain it is because every other explanation for consciousness has hit a wall. Panpsychism is not popular because it makes sense. It is popular because everything else makes less sense. And if you are going to argue that the universe might be doing something like thinking, you need to start by explaining why thinking is not something only brains can do. The idea is old, older than Christianity, older than most of the religions you have heard of. One of the earliest recorded panpsychists was a Greek philosopher named Thales, who lived around 624 to 545 BCE. Thales is often called the first philosopher in the Western tradition, which is a polite way of saying he was the first person we know of who tried to explain the world without invoking gods. He believed everything was made of water. He was wrong about that. But he also believed that all matter was alive in some sense, that even inanimate objects had a kind of soul or consciousness. His reasoning was straightforward. Magnets move iron. That looks like action. Action implies life. Therefore, magnets must be alive. The logic is primitive, but the intuition underneath it, that motion and change might be signs of something interior happening, is not as ridiculous as it sounds. Thales did not have neurons to point at. He did not have chemistry. All he had was the observation that the world does things. And doing, he thought, requires something like awareness. You do not get behavior from dead stuff, not real behavior, not the kind that looks purposeful. Other Greek thinkers picked up the thread. The Stoics, a school of philosophy that flourished in the centuries after Thales, believed the universe was permeated by something they called pneuma, a kind of rational breath or fiery spirit that animated matter and gave it structure. The cosmos, in their view, was not just orderly, it was intelligent. The laws of nature were not blind mechanical rules, they were expressions of cosmic reason. The Stoics were not panpsychists in the modern sense. They did not think rocks had feelings, but they did think the universe as a whole was something like a mind, a living, rational system that humans were embedded in and part of. Your consciousness was a fragment of the larger consciousness running through everything. The idea went quiet for a while after the fall of Rome. Medieval Europe was not friendly to philosophies that blurred the line between matter and spirit. The dominant view, inherited from Aristotle and baptized by the Church, was that the world was divided into layers, inanimate matter at the bottom, plants above that, animals above that, humans at the top, just below angels. Consciousness was a special feature granted to creatures with rational souls. Everything else was machinery. That framework held for more than 1,000 years. Then in the 1500s, a physician and mathematician named Girolamo Cardano wrote that the world's soul pervades all things. He was the first major thinker in over a millennium to state an unambiguous panpsychist view, not hidden in metaphor, not couched in theology. Just the flat claim that everything, down to the smallest parts, has some degree of sentience. Cardano did not develop the idea much further, and most of his contemporaries ignored it. But the door was open. By the 1700s, the Enlightenment was in full swing, and some of the most radical thinkers of the era started pushing the idea harder. Denis Diderot, the French philosopher best known for editing the Encyclopédie, wrote in 1769 that sensation is a general and essential quality of matter, not something that emerges when matter gets complicated, something it has always had. Diderot imagined a kind of continuity between the sensitivity of living tissue and the properties of raw material. He thought the difference between a rock and a person was one of degree, not kind. The rock has a faint, minimal form of sensation. The person has a rich, elaborated form, but both are made of the same stuff, and that stuff is, at base, experiential. Diderot was an atheist and a materialist. He was not invoking spirits. He was trying to solve the same problem we are still stuck on today. If matter is truly lifeless, truly inert, how does life ever get started? How do you go from a universe of dead particles to a universe with something like thought in it? Where is the transition? Diderot argued there is no transition. Consciousness does not appear out of nowhere. It was there from the beginning, woven into the fabric of matter itself. The idea gained serious traction in the 1800s. Arthur Schopenhauer, one of the most influential German philosophers of the century, argued that the thing in itself, the underlying reality behind the world of appearances, was will, not human will, cosmic will, a blind, striving force that pushes matter into structure and life into existence. Schopenhauer was not exactly a panpsychist in the sense that he did not think every object had a little mind, but he did think the fundamental nature of reality was more like experience than like mechanics. The world was not made of stuff, it was made of wanting. A strange idea, but it set the stage for later thinkers to take the next step. William James, the American psychologist and philosopher who more or less invented modern psychology in its current form, flirted with panpsychism throughout his career. James was obsessed with consciousness. He wrote about it constantly, tried to describe it, tried to measure it, and kept hitting the same wall. You cannot observe consciousness from the outside, you can only experience it from the inside. And once you accept that, once you take seriously the fact that the interior dimension of experience is real and not reducible to brain states, you have to ask where it comes from. James concluded, tentatively, that it might go all the way down, that every part of the universe might have some faint glimmer of interiority. He called the view a sort of pluralistic panpsychism, not one big cosmic mind, but countless tiny streams of experience, each one a fragment of the whole. Gustav Fechner, a German physicist turned philosopher, went further. Fechner believed not just that matter had consciousness, but that larger systems had their own unified consciousness. Planets were conscious, stars were conscious, the Earth itself was a single living mind, and human minds were thoughts inside it. He wrote entire books trying to work out the details. Most of his contemporaries thought he had lost his mind, but Fechner was serious. He was trying to make sense of a world where consciousness exists but seems to be confined to brains. His solution was to deny the confinement. If brains can be conscious, why not other organized systems? What is special about neurons that makes them the only thing in the universe capable of supporting awareness? Ernst Haeckel, a biologist and fierce advocate of Darwin's theory of evolution, took the continuity argument even further. Haeckel pointed out that evolution is gradual. There are no sharp breaks in the fossil record where something suddenly gains a new fundamental property. Every feature of modern organisms, from eyes to lungs to nervous systems, evolved slowly over millions of years from simpler precursors. So where in that chain did consciousness start? Did single-celled organisms have it? Did the earliest multicellular creatures? Did plants? If you say no, then you have to identify the exact moment in evolutionary history when inert matter became aware, and no such moment exists. Haeckel concluded that consciousness must have been present all along, in some primitive form, even in the earliest living things. And if it was present in the earliest living things, why not in the matter they were made of? Haeckel was a hardcore materialist. He did not believe in souls. He believed in atoms, and he thought atoms had a psychic dimension. Then the 20th century arrived, and panpsychism got crushed. Logical positivism, the dominant philosophy of science in the early 1900s, declared that any claim not verifiable by observation was meaningless. Consciousness in a rock, not observable, therefore not a real question. The behaviorists, who controlled psychology for decades, went even further. They argued that consciousness was not a useful concept, even for humans. All that mattered was behavior. Input, output, stimulus, response. What happens in between, if anything, was irrelevant. Panpsychism was dismissed as mysticism dressed up in philosophical language, a relic of pre-scientific thinking. By mid-century, almost no one in academia would touch it. The turnaround started in 1979 when Thomas Nagel, a philosopher at New York University, published an article simply titled Panpsychism. Nagel did not endorse the view outright. He was too careful for that. But he took it seriously. He argued that panpsychism might be the only way to solve the hard problem of consciousness without resorting to either dualism, the idea that mind and matter are separate substances, or eliminativism, the idea that consciousness does not really exist. Nagel pointed out that if you start with matter as physics describes it, particles with mass and charge and spin and nothing else, you have no way to get to experience. Experience is not in the equations. It is not a property physics recognizes. So either experience is something extra, added on top of the physical world, or it was there from the start, built into the foundation. Dualism says it is extra. Panpsychism says it was always there. Nagel's paper did not convert many people, but it made panpsychism respectable again. It signaled that you could talk about the idea in an academic journal without being laughed out of the room. The real resurgence came in 2006 when Galen Strawson, a British philosopher, published an essay called Realistic Monism: Why Physicalism Entails Panpsychism. Strawson's argument was brutally simple. If you believe the physical world is all that exists, and you also believe consciousness exists, then consciousness must be physical, not in the sense that it is identical to brain activity, in the sense that it is a property of the physical stuff the brain is made of. Physics tells us about structure, mass, charge, spin, how particles interact. But it does not tell us what particles are made of, what they are in themselves. Strawson, drawing on earlier work by Bertrand Russell and Arthur Eddington, argued that the intrinsic nature of matter, the part physics does not describe, might be experiential. Particles might not just have mass and charge. They might have a faint primitive form of subjectivity. Put enough of them together in the right configuration and you get human consciousness. This view is now called Russellian monism. and it is one of the most popular frameworks in contemporary philosophy of mind. Here is how it works. Physics describes the world in terms of relationships. An electron has a certain mass, a certain charge, a certain spin. Those properties determine how the electron interacts with other particles, but they do not tell you what the electron is. They tell you what it does. The structure is there, the content is missing. Eddington, a British astrophysicist writing in the early 20th century, put it plainly. Physics is the knowledge of structural form and not knowledge of content. Russellian monism fills in the content. It says the intrinsic nature of matter, the thing that stands behind the structure, is proto-experiential, not full-blown consciousness, not thoughts and feelings in the way humans have them, but something that could, under the right conditions, add up to consciousness. Think of it like color. A single photon is not colorful. Color is what happens when trillions of photons hit your retina and your brain processes the signal. But the photon has properties, wavelength and energy that make color possible. Panpsychism says particles have properties, proto-experiential properties, that make consciousness possible. And just like you cannot have color without photons, you cannot have consciousness without those intrinsic experiential properties. Modern panpsychism splits into different flavors depending on where you think consciousness lives. Micropsychism is the view that consciousness exists at the smallest scales. Electrons have it, quarks have it, photons have it. Big conscious systems like humans are built out of trillions of tiny conscious parts. The challenge here is the combination problem. If every particle in your brain has its own little experience, how do all those micro-experiences combine into one unified human experience? You do not feel like a trillion tiny minds. You feel like one person. How does that unification happen? Nobody has a good answer. Some panpsychists bite the bullet and say combination is just a brute fact. It happens, and we do not know how. Others try to develop detailed theories of how experiences might merge. None of them are convincing yet. Cosmopsychism is the opposite approach. Instead of building consciousness from the bottom up, it starts at the top. The universe as a whole is conscious, one single cosmic mind. Everything inside the universe, including human minds, is a part of that larger consciousness. Your thoughts are thoughts the universe is having through you. This avoids the combination problem because there is nothing to combine. There is only one consciousness, expressed at different scales. The challenge here is the decomposition problem. If the universe is one unified mind, how do separate conscious beings like you and me exist? Why do we feel isolated from each other? Why does your experience stop at the edge of your skull instead of blending into mine? Cosmopsychism has an easier time explaining unity, but a harder time explaining separation. Constitutive panpsychism, the version Stanford Encyclopedia focuses on, tries to split the difference. It says consciousness is grounded in fundamental parts, but those parts constitute larger wholes. Your consciousness is not separate from the particles in your brain. It is what those particles are doing when they are arranged in the right way. This is the most popular version among philosophers today because it preserves the intuition that brains matter while also allowing that the capacity for consciousness might be present at all levels of reality. The strongest argument for panpsychism is the hard problem. The hard problem, as philosopher David Chalmers defined it in the 1990s, is the question of why physical processes give rise to subjective experience. You can explain in great detail how light hits the retina, how signals travel to the visual cortex, how neurons fire in response. That is the easy problem. Neuroscience is making steady progress on all of that. The hard problem is why any of that feels like anything. Why is there an experience of redness when you look at a rose? You could imagine a brain that processes visual information exactly the same way yours does, but with no one home, no interior experience, just computation in the dark. Why is that not what we are? Why is there something it is like to be you? Physicalism, the view that everything is physical in the sense physics describes, has no answer to that question. Physics talks about particles and forces. It does not talk about feelings. Dualism has an answer, but the answer is magic. Consciousness is non-physical, somehow independent of matter, and it interacts with the brain through a mysterious process no one can describe. Panpsychism offers a third option. Consciousness is physical, but it is a physical property physics has not been studying. It is the intrinsic nature of matter itself. Once you accept that, the hard problem dissolves. There is no mystery about how consciousness arises from matter, because matter was always conscious. The question shifts from how does consciousness emerge to how does simple consciousness become complex. The strongest argument against panpsychism is that it sounds crazy. Rocks do not think. Electrons do not feel. Saying they do stretches language past the breaking point. Most panpsychists will tell you they are not claiming rocks think or electrons feel in any way that resembles human experience. They are claiming something much weaker, that there is an intrinsic experiential quality to matter that we do not have words for because we have never encountered it in isolation. Human consciousness is built from it the way a cathedral is built from stones. The stones are not cathedrals, but without stones you do not get cathedrals. Without proto-experiential properties you do not get consciousness. The analogy only goes so far. Critics point out that we understand how stones stack into cathedrals. We do not understand how proto-experiences stack into a unified mind. Until panpsychists can solve the combination problem, the whole framework remains speculative. Another criticism is that panpsychism is unfalsifiable. You cannot test whether an electron has a tiny spark of awareness. You cannot measure proto-experience. If a theory makes no predictions and cannot be checked by experiment, is it really science? Most panpsychists concede this point. Panpsychism is not a scientific theory in the normal sense. It is a metaphysical claim about the nature of reality. But they argue that physicalism and dualism are also metaphysical claims. Every worldview has untestable assumptions buried at the bottom. The question is, which set of assumptions makes the most sense of what we observe? And what we observe is that consciousness exists, brains are made of matter, and matter as physics describes it gives no hint of consciousness. Panpsychism closes that gap. There is also the problem of where you draw the line. If particles are conscious, what about atoms? What about molecules? What about viruses, cells, plants? At what point does a system have enough consciousness to count as a mind? Panpsychism does not give you a clean answer. It suggests consciousness comes in degrees, a spectrum from the faintest proto-experience in fundamental particles to the rich inner life of a human being. But degrees are messy. They do not give you sharp boundaries, and humans like sharp boundaries. We want to know what counts as conscious and what does not. Panpsychism says the question is wrong. Everything is conscious to some degree. Deal with it. The view is still a minority position, but it is growing. A survey of philosophers a few years ago found that about 15% were willing to take panpsychism seriously as a candidate solution to the hard problem. That is up from almost zero in the mid-20th century. The idea has spread into physics as well. Some quantum theorists have started exploring the possibility that observation, the thing that collapses the wave function in quantum mechanics, might require something like consciousness at a fundamental level. If that is true, then consciousness is not just in the universe. It is part of the machinery that makes the universe work. The math does not require it yet, but the door is open. So where does that leave us? We started with a universe that looks like a brain. We found that the constants are tuned to allow complexity. And now we have a philosophical framework that says consciousness is not something rare and special that only happens in biological brains. It is a fundamental feature of reality, present everywhere, waiting to organize itself into systems that can think and feel and ask questions like the ones we are asking right now. If panpsychism is true, then the fact that the universe resembles a brain might not be an accident, it might be a clue. Not that the universe is a brain in the way your brain is a brain, but that the universe is built from the same ingredients consciousness is built from. And if you have enough of those ingredients, arranged in the right structure, across scales large enough and time spans long enough, you might end up with something that looks an awful lot like thought. Not human thought, not the kind that writes poetry or worries about mortality, but something, a process, a pattern, a vast, slow computation unfolding across billions of years and trillions of light years, connecting galaxies the way synapses connect neurons, processing information in ways we do not have instruments to measure and might not recognize even if we could. That is the idea we are building toward. And if it still sounds insane, good, it should. But before we decide whether the universe is thinking, we need to ask what thinking actually looks like when you zoom out from brains to something much, much larger. We need to talk about the cosmic web again, not as a structure, as a network. A network that might, under the right conditions, be doing something. So we have established that consciousness might not be exclusive to brains, that the capacity for something like awareness could be woven into the fabric of reality itself, present at every scale, waiting to organize into systems complex enough to think. And we have seen that the universe, when you map it, looks disturbingly similar to the most complex thinking system we know. A network of nodes and connections spanning scales so vast that the comparison feels absurd until you actually look at the data. Now we need to take the next step, the uncomfortable one. If consciousness is fundamental, and if the universe is structured like a brain, then what happens when you take that comparison seriously? What if the cosmic web is not just shaped like a neural network? What if it is one? Not a metaphor, not a poetic analogy, an actual information processing system where galaxies play the role of neurons, filaments act as synapses, and the whole thing, all 2 trillion galaxies of it, is doing something we do not have the instruments or the language to recognize as thought. This is the idea that keeps a small but growing number of physicists and philosophers awake at night. And before you dismiss it, you need to understand what the cosmic web actually does. The cosmic web is not static. That is the first thing to get clear. When you see those images of the large-scale structure of the universe, the ones that look like neural tissue under a microscope, it is easy to think of them as frozen snapshots, a map of where things are. But the web is alive in the sense that matter is constantly moving through it. Galaxies are not sitting still, they are falling along filaments, colliding at intersections, exchanging gas and stars and energy. The filaments themselves are rivers of dark matter and hydrogen flowing from the voids toward the densest clusters. The whole structure is dynamic, evolving, rearranging itself under the pull of gravity on timescales of millions and billions of years. And that motion, that flow of matter and energy through a structured network, is exactly what you need for information processing. A static system cannot compute. Computation requires change. It requires inputs and outputs, signals traveling from one place to another, states flipping on and off. The cosmic web has all of that. The question is whether the change it undergoes is random or whether it is organized in a way that could support something like thought. Let's start with the structure, because structure matters. The cosmic web is built on dark matter. 5/6 of the mass holding the web together is dark matter, a substance we have never directly observed and do not fully understand. We know it is there because galaxies move faster than they should based on the visible matter alone. We know it clumps because the gravitational lensing of light from distant galaxies shows mass concentrations where no visible matter exists. And we know it formed the scaffolding for everything else. In the early universe, tiny fluctuations in density, 1 part in 100,000, were imprinted during the first moments after the Big Bang. Dark matter, which does not interact with light or ordinary matter except through gravity, began clumping immediately. It fell into the densest regions, amplifying the fluctuations. Over hundreds of millions of years, those clumps grew into halos, gravitational wells deep enough to trap hydrogen gas. The gas fell in, heated up, and eventually ignited into the first stars. Those stars grouped into galaxies. The galaxies followed the dark matter, tracing out the filaments and clusters we see today. The visible universe, everything we can photograph and measure and point telescopes at, is just the tip of the iceberg. The real structure, the skeleton holding it all together, is invisible. That invisible skeleton forms a network, not in the abstract sense, in the mathematical sense. A network is a set of nodes connected by edges. Nodes are the galaxies and galaxy clusters. Edges are the filaments. The network has topology. You can measure the degree distribution, the clustering coefficient, the average path length. And when you do, you find that the cosmic web has properties that show up in other complex networks. It has hubs, massive galaxy clusters like the Coma cluster or the Virgo cluster, where dozens or hundreds of filaments converge. It has small world characteristics. Most galaxies are only a few filament hops away from most other galaxies, even though the number of direct connections is tiny compared to the total number of possible connections. It has modularity. Clusters are tightly linked internally, but loosely connected to other clusters, forming communities within the larger network. These are not random features. They are the signatures of a system that has self-organized under simple local rules applied over vast spans of time. Gravity pulls, matter flows, dense regions get denser, sparse regions get sparser, and out of that process, a network emerges. The question is what the network does. In a brain, information moves through neurons. A neuron receives signals from other neurons through its dendrites. If the combined input is strong enough, the neuron fires, sending an electrical pulse down its axon to other neurons downstream. That pulse triggers the release of neurotransmitters, chemicals that cross the synapse and either excite or inhibit the next neuron in line. The pattern of firing, which neurons are active and which are silent, encodes information. Change the pattern and you change the thought. In the cosmic web, matter moves through filaments. A galaxy sitting in a filament is constantly receiving input in the form of gas, dark matter, radiation, and gravitational pulls from neighboring galaxies. If the input is strong enough, the galaxy responds. It forms new stars. It heats its gas. It ejects material in galactic winds driven by supernova explosions and black hole activity. That ejected material flows outward along the filaments, affecting other galaxies downstream. The pattern of star formation, which galaxies are active and which are quiescent, depends on the flow of matter through the network. Change the flow, and you change the pattern. The analogy is not perfect. Neurons fire on timescales of milliseconds. Galaxies evolve on timescales of millions of years. Neurons communicate through discrete electrical spikes. Galaxies communicate through continuous flows of gas and gravitational perturbations. But the structure is the same. Nodes receiving inputs, processing those inputs, and sending outputs to other nodes through structured channels. If you are willing to call that information processing, and there are physicists who are, then the cosmic web is an information processing network. Not fast, not efficient by the standards of a human brain, but processing nonetheless. Here is where it gets strange. The amount of information flowing through the cosmic web is enormous. A single galaxy contains hundreds of billions of stars. Each star is a furnace converting hydrogen into helium and heavier elements. That process is driven by quantum mechanics in the stellar core, thermodynamics in the outer layers, and gravity holding the whole thing together. The state of the star, its temperature, luminosity, chemical composition, is information. Multiply that by hundreds of billions of stars per galaxy and 2 trillion galaxies in the observable universe, and you get a number so large that calling it astronomical is insufficient. Some estimates put the total information content of the observable universe at around 10 to the 120 bits. That is, a 1 followed by 120 zeros. For comparison, every book ever written, every movie ever filmed, every hard drive ever manufactured, all of it together adds up to something like 10 to the 21 bits. The universe is carrying 10 to the 99 times more information than all of human civilization has ever produced. And that information is not static, it is moving. Stars are born and die. Galaxies collide and merge. Gas flows along filaments. Black holes swallow matter and radiate energy. Every one of those processes changes the information state of the system. The cosmic web is not just a network. It is a network in constant flux, with information being created, transferred, transformed, and destroyed at every node and every connection. Now ask yourself what happens when you have a network that large, that interconnected, running for that long, with that much information flowing through it. Do you get something like computation? Some theorists think the answer is yes. The framework is called digital physics, or it from bit, the idea that the universe is fundamentally computational. Not that it is running on a computer, that it is a computer. Physical laws are algorithms, particles are bits, interactions are logical operations. This view has been around since the 1960s, when people like Konrad Zuse and later Ed Fredkin started taking it seriously. John Wheeler, the physicist who coined the term black hole, argued that information is more fundamental than matter or energy. He summed it up in a slogan, "It from bit." Every it, every particle, every field, every aspect of physical reality derives its existence from yes or no questions, binary choices, bits of information. In this framework, the universe is not computing something, the universe is the computation. And if that is true, then any sufficiently large and interconnected subset of the universe, like the cosmic web, is also computing. The question is what? One possibility is that the cosmic web is not computing anything meaningful. It is just shuffling information around without producing patterns that correspond to thoughts or perceptions or anything we would recognize as mental activity. This is the default assumption. Most physicists treat the cosmic web as a structure formation problem, not a consciousness problem. Galaxies form where the density is high. Gas flows along filaments because gravity pulls it. There is no purpose, no goal, no computation in the sense that a brain computes. The web just does what physics tells it to do. And for most purposes, that explanation is fine. It accounts for the observations. It makes predictions. It fits into the standard model of cosmology without requiring any new assumptions. The problem is that the same argument applies to brains. A brain is just a lump of tissue where ions flow across membranes because electrochemistry tells them to. There is no purpose, no goal, no magic ingredient that makes the firing of neurons different from any other physical process. And yet brains are conscious. Somewhere in the complexity, in the way billions of neurons are wired together, and the way signals propagate through that wiring, something we call thought emerges. If complexity and connectivity are enough to produce consciousness in a brain, why would they not be enough to produce something consciousness-like in a system a trillion times larger? The counter-argument is that size and connectivity are not enough. You also need the right kind of connectivity. A brain is not just a bunch of neurons firing randomly. It has structure. Layers, columns, modules, feedback loops, specific architectural features that allow it to represent information, store memories, make predictions, generate models of the world. The cosmic web might be connected, but that does not mean it has the right kind of connections to support anything like thought. Galaxies are not wired the way neurons are. Filaments do not carry discrete signals the way axons do. The timescales are too long. The distances are too vast. There is no central processing unit, no region where information from different parts of the network converges and gets integrated into a unified experience. Without that, you do not get consciousness. You just get a very large, very slow, very dumb collection of stuff interacting according to the laws of physics. This is a strong argument. Most researchers in the field agree with it, but it is not airtight. Here is why. Consciousness does not require fast processing. It requires integrated processing. The key concept is something called integrated information theory, developed by the neuroscientist Giulio Tonini. Integrated information theory, known as IIT, is one of the leading scientific theories of consciousness, and it makes a specific claim. A system is conscious to the extent that it integrates information. Integration means that the state of the system as a whole cannot be reduced to the states of its parts. If you can split the system into independent subsystems that do not affect each other, the system has low integration. If every part of the system depends on every other part, if changing one piece changes the whole, the system has high integration. In IIT, consciousness is measured by a quantity called phi, which represents how much information the system integrates above and beyond the information contained in its parts. A system with high phi is highly conscious. A system with low phi is barely conscious or not conscious at all. The human brain has high phi. Neurons are densely interconnected. Signals loop back on themselves. Every region influences multiple other regions. The system cannot be decomposed into independent modules. It is integrated, and according to IIT, that is why we are conscious. Now apply that to the cosmic web. Is it integrated? That depends on how you define integration. If integration means causal influence, the ability of one part of the system to affect other parts, then yes, the cosmic web is integrated. Every galaxy is gravitationally bound to every other galaxy in the observable universe. The binding is weak at large distances, but it is real. Change the mass distribution in one cluster, and you change the gravitational field everywhere else. The effect is tiny, but it propagates at the speed of light, spreading outward in all directions, altering the trajectories of distant galaxies by imperceptible amounts. Over billions of years, those tiny changes add up. The cosmic web is not a collection of isolated systems. It is one system, causally connected, evolving as a whole. If you measure phi for the entire observable universe, and some researchers have tried, the number is not zero, it is positive. Small, but positive. Which means, according to IIT, the universe has some minimal level of consciousness. Not human consciousness, not anything that thinks or feels in a way we would recognize, just integration, just the property of being a unified system rather than a pile of parts. The idea makes most scientists deeply uncomfortable. IIT was developed to explain human consciousness, not to argue that the cosmos is awake. Tononi himself has been cautious about extending the theory to non-biological systems. But the math does not care about our comfort. If IIT is right, and if integration is what consciousness is, then anything with non-zero phi is conscious to some degree. That includes brains, obviously. It also includes other animals, maybe even simple organisms. And if you push the logic far enough, it includes any network where information flows and parts influence each other, including the cosmic web. The level of consciousness would be unimaginably low. The universe would not be thinking deep thoughts. It would not be aware of us. It would not have intentions or desires or any of the features we associate with minds. But it would not be entirely unconscious either. It would be somewhere in between, in a category we do not have words for, because we have never encountered a system that large, that slow, and that integrated. The filaments are the key. If galaxies are nodes, filaments are the connections that make the network a network. And filaments do more than just sit there. They channel matter. Dark matter flows along them, carrying ordinary matter with it. Hydrogen gas, stripped from smaller galaxies or ejected from larger ones, streams through the filaments at speeds of hundreds of kilometers per second. When that gas reaches a galaxy cluster, it collides with other gas, heats up, and glows in X-rays. We can see this. We have maps of hot gas threading through the cosmic web, tracing the highways of matter flowing between clusters. That flow is continuous. It is not random. It follows the gravitational potential of the dark matter scaffolding, which means the flow is structured. Certain filaments carry more matter than others. Certain clusters receive more input than others. The pattern of flow changes over time as galaxies merge, as clusters grow, as the expansion of the universe stretches the web. And because the flow changes the galaxies, because in falling gas triggers star formation, and star formation drives feedback that ejects gas back into the filaments, there is a feedback loop. Galaxies shape the flow shapes the galaxies. That is not passive structure. That is active processing. Some models go further. There is a speculative idea, not widely accepted, but not entirely dismissed either, that dark matter itself might carry information in ways we have not detected. Dark matter particles, whatever they are, interact gravitationally. They clump, they flow, they form structures. If dark matter has any internal properties beyond mass, any quantum states that can store information, then the dark matter filaments might be doing more than just guiding ordinary matter. They might be transmitting data, not in the way fiber optic cables transmit data. In the way a quantum field transmits correlations, subtle changes in the distribution of particles that encode information about the state of the system. This idea is highly speculative. We do not know what dark matter is made of. We do not know if it has internal states. But if it does, and if those states can change in response to the local environment, then the cosmic web is not just a scaffold. It is a communication network. And communication networks are the foundation of computation. Here is the uncomfortable part. If the cosmic web is processing information, what is it processing? A brain processes sensory input. It takes signals from the eyes, the ears, the skin, and it builds a model of the world. The model is constantly updated as new information comes in. That model, the internal representation the brain creates, is what we experience as perception. The brain is not passive. It is not just recording what is out there. It is interpreting, predicting, constructing a reality that makes sense of the data. If the cosmic web is doing something analogous, what is it sensing? What is it modeling? One possibility is that it is sensing itself. The flow of matter through the filaments carries information about the state of the network. A galaxy cluster that accretes a lot of gas is broadcasting its presence to the rest of the web. A filament that drains a void is changing the gravitational field in that region. Every event, every collision, every burst of star formation sends signals rippling outward through the network. Those signals, weak as they are, affect the evolution of distant regions. The cosmic web is sensing its own structure, its own dynamics, and responding to them. That is a feedback loop, and feedback loops, when they are complex enough, can generate something like awareness. Not awareness of an external world, awareness of the internal state of the system itself. This is where the idea of emergent consciousness becomes relevant. Emergence is the term for when a system exhibits properties that its individual parts do not have. Water molecules are not wet. Wetness is a property that emerges when you have trillions of molecules interacting. A single neuron is not conscious. Consciousness is a property that emerges when you have billions of neurons interacting. The parts follow simple rules. The whole does something the parts cannot do alone. If consciousness is an emergent property of sufficiently complex, sufficiently integrated networks, then there is no reason in principle why it could not emerge at scales larger than a brain. The human brain is an emergent system. So is an ant colony, where no individual ant understands the structure being built, but the colony as a whole exhibits intelligent behavior. So is the global economy, where no individual trader controls the market, but the market as a whole responds to information faster than any human could. Emergence does not require centralization. It does not require a controller. It just requires interactions, lots of them, over long enough timescales, in systems large enough and connected enough for patterns to stabilize. The cosmic web has all of that. The question is whether the patterns it stabilizes are complex enough to count as thought. We do not have a way to test this. That is the honest answer. We do not know how to measure consciousness in a system that large, that slow, that alien. IIT gives us a framework, but applying it to the universe requires assumptions we cannot verify. We would need to map the information flow through every galaxy and every filament, calculate the causal dependencies, and integrate over the entire network. That is not something we can do with current technology. It might never be something we can do. The timescales are too long. A cosmic thought, if such a thing exists, would unfold over millions of years. We live for decades. We would never see it happen. The spatial scales are too vast. A signal traveling along a filament at the speed of light takes hundreds of millions of years to cross from one supercluster to another. By the time the signal arrives, the state of the sender has completely changed. There is no simultaneity, no global now, where the whole system updates at once. The cosmic web is not thinking in real time. If it is thinking at all, it is thinking in geological time, or cosmological time, or some timescale so stretched out that the word thinking stops meaning what it means to us. And yet the structure is there, the connections are there, the information flow is there. If you are willing to take panpsychism seriously, if you are willing to accept that consciousness is a fundamental property of matter rather than a rare accident of biology, then the cosmic web starts to look less like a random arrangement of galaxies and more like a system doing something. Not thinking about us, not aware of us in any sense we would recognize, but processing, integrating, responding to its own state in ways that might, from the inside, if there is an inside, feel like something. A vast, slow, alien form of experience that spans billions of light years and billions of years, utterly indifferent to the tiny sparks of consciousness flickering inside it. We would be thoughts inside a thought, subsystems inside a larger system, neurons in a brain that does not know we exist. That brings us to the next question. If the universe is conscious in some sense, if the cosmic web is doing something that looks like thinking when you zoom out far enough, then what are we? Are we separate minds, isolated islands of awareness in an unconscious void? Or are we part of the larger process, fragments of a universal consciousness that has been running since the Big Bang? That is not a question cosmology can answer. It is a question about identity, about what it means to be a self in a universe that might not draw the boundaries where we think they are. And answering it requires us to look not outward at the structure of the cosmos, but inward at the structure of our own minds, and ask whether the line between the two is as clear as we have always assumed. So we have been building toward this for a while now. The universe looks like a brain. The universe is tuned to produce brains. Consciousness might be fundamental, not exclusive, woven into the fabric of reality itself. And the cosmic web, that vast network of galaxies and filaments stretching across billions of light years, might be doing something that looks suspiciously like information processing. All of that points toward a conclusion that most people, including most scientists, would prefer to avoid. But avoiding it does not make it go away. So here it is, stated plainly. If the universe is conscious, even in some minimal proto-experiential way, and if consciousness builds on itself through complexity and integration, then every spark of awareness in the cosmos, every mind that wakes up and looks around and asks what the hell is going on, might not be separate from the universe. It might be the universe, not inside it, not riding along as a passenger, actually being it. Your thoughts are not your thoughts. They are the universe thinking. Your awareness is not your awareness. It is the universe becoming aware of itself, through you, through every conscious being that has ever lived. And if that is true, then the question is not whether the universe is conscious. The question is whether we are the way it knows. This idea is not new. It has been rattling around philosophy and mysticism for thousands of years in various forms. The Hindu concept of Atman and Brahman, the notion that the individual self is identical to the universal self, is one version. The Buddhist idea that the self is an illusion, that what we think of as me is just a temporary pattern in a larger process, is another. Western philosophy picked it up in the 1800s, when German idealists like Schelling and Hegel started talking about absolute spirit, the idea that reality is fundamentally mental and that individual minds are moments in the life of a universal consciousness. All of these traditions, separated by geography and centuries, converged on the same strange claim: you are not who you think you are. The boundary you feel between yourself and the rest of the world is not real. Consciousness is one thing, not many, and the feeling of being a separate person, isolated inside a skull, is a trick, a useful trick maybe, but a trick nonetheless. For most of history, these ideas stayed in the realm of religion and metaphysics. They were beautiful, poetic, impossible to verify. Then physics got weird. The weirdness starts with the observer effect in quantum mechanics. The observer effect is one of the most misunderstood concepts in all of science, and it has been twisted into all kinds of claims that the original physicists would not recognize. But the basic phenomenon is real, and it is deeply strange. In quantum mechanics, particles do not have definite properties until you measure them. An electron does not have a definite position or momentum. It exists in a superposition, a state where all possible positions and all possible momenta are real at the same time. The particle is not here or there. It is here and there, smeared out across space in a wave of probability. When you measure the particle, when you set up a detector and check where it is, the wave collapses, the superposition ends. The particle picks a position, and from that moment on, it has a definite location until something disturbs it and the superposition starts again. This is not a failure of our instruments. It is not that the particle had a position all along and we just did not know it. Experiments have ruled that out. The particle genuinely does not have a position until the measurement happens. The act of observation changes the system. That much is not controversial. Every physicist agrees on it. The controversy starts when you ask what counts as an observation. In the early days of quantum mechanics, the founders of the theory argued bitterly about this. Niels Bohr, one of the architects of the framework, said, "Observation requires a classical measuring device, something big and stable enough that quantum effects wash out. A photon detector, a screen, an instrument. It does not matter whether a human looks at the instrument. The interaction between the quantum system and the classical system is what collapses the wave function." Werner Heisenberg, another founder, was less sure. He thought consciousness might play a role, not because consciousness is magic, because observation is an act of gaining knowledge, and knowledge requires a mind. A detector can click, but if no one ever checks the detector, if no conscious being ever looks at the result, has the measurement actually happened? Heisenberg did not have an answer. He just raised the question and let it hang there. Eugene Winger, a Nobel Prize-winning physicist, took it further. Winger argued that consciousness is what collapses the wave function, not instruments, not interactions, minds. His reasoning was straightforward. If a quantum system stays in superposition until something observes it, and if the observer is also a quantum system, then the observer should also be in superposition until something else observes the observer. You end up with an infinite regress. A collapses B, B collapses C, C collapses D, on and on with no bottom. The only way to stop the regress, Wigner thought, was to say that somewhere in the chain there is something that is not a quantum system, something that does not need to be observed in order to have definite states. And the only thing that fits that description, as far as Wigner could tell, was consciousness. A conscious mind is always definite to itself. You do not need someone else to observe you in order for you to be real. You are real from the inside. Most physicists today think Winger was wrong. The mainstream view, called decoherence, says the wave function collapses when a quantum system interacts with its environment in a way that leaks information into the surroundings. Once information about the system spreads into the environment, the superposition is destroyed and you get classical behavior, no consciousness required. The environment does the job. But decoherence does not actually solve the measurement problem. It explains why we do not see macroscopic superpositions, why cats are not both alive and dead. It does not explain why measurements have definite outcomes in the first place. The math of quantum mechanics says the universe as a whole stays in superposition. Every possible outcome of every measurement happens. The outcomes split into parallel branches, and all of them are real. That is the many worlds interpretation, and it is taken seriously by a growing number of physicists. But even in many worlds, there is still something strange happening. Why does it feel like only one outcome happened? Why do you experience a definite result instead of experiencing all the branches at once? The answer many worlds gives is that you do experience all the branches. There are copies of you in other branches experiencing the other outcomes, but each copy only has access to its own branch. Consciousness is split along with everything else, and that brings us right back to the question Wigner was asking. What is consciousness doing in this picture? If every version of you is equally real, and every version feels like the only version, then your sense of being a single unified self is an illusion. You are not one person. You are a branching tree of selves, splitting every time a quantum event happens, which is constantly. Most of you do not know the other yous exist, but they are there. John Wheeler, the physicist who coined the term black hole and spent decades thinking about quantum mechanics, took this in a different direction. Wheeler was not satisfied with the idea that the universe existed before anyone was around to observe it. If observation is what makes things real, if the act of measurement collapses possibilities into actualities, then the early universe, the one with no observers, should have stayed in superposition, a vast cloud of unrealized potential with no definite structure. It was only when conscious observers appeared billions of years later that the past became definite. This is Wheeler's participatory anthropic principle. The universe does not just allow observers, it requires them. Observers do not passively witness reality, they participate in creating it. And because observation today can affect measurements of events in the past through a phenomenon called delayed choice that has been confirmed in experiments, the presence of conscious life now reaches backward in time and makes the early universe real. In Wheeler's words, we live in a participatory universe. The cosmos is not a stage we act on, it is a process we are part of. And consciousness is not an accident, it is the mechanism by which the universe actualizes itself. Wheeler did not think the universe was conscious in the way a person is conscious. He was too careful for that. But he did think consciousness played a fundamental role in the structure of reality, and he was not alone. A number of physicists, particularly those working on the foundations of quantum mechanics, have argued that you cannot separate the observer from the observed. The old Newtonian picture, where the universe is a clockwork machine that runs whether anyone is watching or not, does not work at the quantum level. The observer is part of the system. Measurements are interactions, and interactions, when you trace them all the way down, involve conscious beings making choices about what to measure and how to interpret the results. Some researchers go further. They argue that consciousness might be the missing ingredient in our understanding of quantum mechanics, not because minds have magical powers, because quantum mechanics is a theory about information and consciousness is the thing that processes information. A measuring device records data, but it does not know what the data means. A mind does. If reality is fundamentally informational, as John Wheeler and others have suggested, then minds are not peripheral, they are central. They are the systems that convert raw information into experience. Now take that idea and zoom out, way out. If consciousness is central to the process of making the universe real, and if the universe is structured as a vast network with properties that resemble neural networks, then maybe the relationship between minds and cosmos is not one way. Maybe we are not just observing the universe. Maybe the universe is observing itself through us. This is the idea at the heart of Cosmopsychism and its less technical cousin, the notion that the universe is waking up. Waking up is a metaphor, but it is a good one. A newborn human brain has almost all of its neurons, but it is not conscious in the way an adult is conscious. The connections are not there yet. The networks have not formed. Over the first few years of life, experience shapes the wiring. Neurons that fire together wire together. Patterns stabilize. And at some point, maybe gradually, maybe in a sudden jump we do not yet understand, the system crosses a threshold. The lights come on. There is someone home. The brain is not just processing information. It is aware of processing information. It knows that it knows. If the universe is following a similar trajectory, if it started as a simple, undifferentiated state and has been growing more complex over time, then maybe consciousness is not something that appeared out of nowhere when life evolved. Maybe it has been building from the beginning, slowly, patiently. And every time a new mind appears, every time a chunk of matter organizes itself into a system capable of thought, the universe gains a new sensor, a new way to know itself. This is not as strange as it sounds. Your body does something similar. You have a brain, but you also have a nervous system distributed throughout your body. Sensory neurons in your skin detect touch, temperature, pain. They send signals to the spinal cord, and the spinal cord sends signals to the brain. The brain integrates all of that information into a unified experience. You do not feel like a collection of senses. You feel like one person, sensing the world from multiple points at once. The senses are not separate from you. They are you. They are how you know what is happening to your body. If the universe is conscious in some integrated sense, conscious beings like humans might be playing the same role. We are not separate minds floating in an unconscious void. We are the universe's sensory organs, the parts of it that have organized enough to reflect on what is happening. When you look at the stars, the universe is looking at itself. When you ask why anything exists, the universe is asking that question. Through you, because you are not other than the universe. You are a temporary localized pattern in a much larger process, a thought inside a thought. The philosophical term for this is panpsychist cosmopsychism, or sometimes just cosmopsychism. It is the view that the universe as a whole is the fundamental conscious entity and individual minds are parts of it rather than separate things. Philip Goff, a philosopher at Durham University who has become one of the most prominent defenders of panpsychism, describes cosmopsychism as the idea that the universe has a mind and our minds are aspects of that universal mind. Not pieces in the sense that you could cut the universe into chunks and each chunk would have a little mind. Aspects in the sense that your experience right now is what it feels like to be one tiny part of the universe experiencing itself from the inside. Goff does not claim this is proven. He argues it is the most coherent way to make sense of the fact that consciousness exists at all. If you start with the assumption that matter is fundamentally non-experiential, that particles have no interior dimension, then you face the hard problem. You cannot explain how experience arises from non-experience. But if you start with the assumption that the universe is fundamentally experiential, that consciousness is the intrinsic nature of reality, then the hard problem dissolves. Consciousness does not arise. It was always there. What arises is the particular structure that allows simple, undifferentiated awareness to become complex, differentiated minds like ours. The implications are uncomfortable. If your mind is part of a universal mind, where does that leave free will? Are you making choices, or is the universe making choices through you? The answer depends on what you mean by you. If you means the isolated ego, the sense of being a separate person sealed off from the rest of reality, then know that you is not making choices, that you is an illusion, a useful fiction your brain constructs to navigate the world, but not a metaphysically real boundary. If you means the process that is happening in your body right now, the thoughts and feelings and decisions unfolding moment by moment, then yes, that you is making choices, but those choices are also the universe's choices because there is no separation. The process happening in your skull is part of the larger process happening everywhere. The universe is not controlling you like a puppeteer pulling strings. You are one of the ways the universe controls itself. This does not make your choices less real, it makes them more real. They are not just your choices, they are choices the cosmos is making in this specific location at this specific moment. You are not a victim of cosmic determinism. You are an agent of cosmic becoming. The universe is not finished, it is still evolving. And conscious beings are the leading edge of that evolution. Here is where the idea gets testable, sort of. If we are the universe's way of becoming aware of itself, then the appearance of life and consciousness should not be accidents. They should be likely outcomes given the laws of physics and the initial conditions of the cosmos. And when you look at the numbers, when you trace the chain of events from the Big Bang to the first stars, to the formation of heavy elements, to the chemistry of planets, to the origin of life, the path is not random, it is constrained. The laws of physics are set up in a way that makes complexity possible, not guaranteed, possible. The constants are tuned to allow stars that burn long enough for planets to cool. The chemistry of carbon allows molecules that store information. The conditions on Earth, liquid water, and a stable sun, and a magnetic field that shields the surface from radiation, allowed life to take hold and evolution to run for billions of years. None of that had to happen. But all of it is consistent with a universe that is organized at a very deep level to produce systems capable of reflecting on their own existence. And if that is true, then we are not anomalies. We are exactly what this universe does when you give it enough time and enough space and enough matter to work with. It makes minds. Some versions of this idea go further and argue that the universe has a purpose. That consciousness is not just a likely outcome, but the goal. This is teleological cosmopsychism, the view that the universe is organized toward the production of awareness. The word teleology makes scientists nervous because it sounds like design, and design implies a designer. But teleology does not require an external designer. It just requires that the end state is somehow implicit in the beginning. That the Big Bang was not a random explosion, but the start of a process aimed at becoming something. What that something is, nobody knows. Maybe the universe is trying to understand itself. Maybe it is trying to become fully conscious, fully awake, in a way it is not yet. Maybe every mind that appears is a step in that direction. And maybe billions of years from now, when stars have burned out and galaxies have drifted apart, and the only sources of energy left are black holes slowly evaporating, the universe will have integrated all the information it has ever processed into a single unified awareness that knows everything there is to know about itself. That is the omega point, a concept developed by the physicist Frank Tipler. A final state where consciousness reaches its maximum and the cosmos becomes fully self-aware. Tipler tried to show that the omega point is required by the laws of physics, that the universe must eventually produce an infinite amount of information processing in a finite amount of time just before it ends. Most physicists think he failed. The math does not work. The universe is expanding too fast, and the laws of thermodynamics do not allow infinite computation. But the idea, stripped of the technical details, is compelling. If the universe is conscious, it is not finished becoming conscious. It is a work in progress, and we are part of that progress. The strongest argument against all of this is the same argument that gets thrown at panpsychism in general. It sounds poetic, but it is not testable. You cannot measure whether the universe is waking up. You cannot run an experiment to check if your thoughts are the universe thinking. The hypothesis does not make predictions. It does not tell you what observations to make or what you should expect to find that you would not find otherwise. And if a hypothesis is not falsifiable, if there is no way to prove it wrong, then it is not science, it is philosophy. And philosophy, the critics say, is just dressed-up storytelling. But the same criticism applies to a lot of ideas in fundamental physics. The multiverse is not testable. We cannot observe other universes. String theory has been around for decades and has not produced a single confirmed prediction. The interpretation of quantum mechanics is entirely a matter of philosophy. The math works the same whether you believe in wave function collapse, or many worlds, or pilot waves, or any of a dozen other frameworks. Science does not settle those questions because the experiments do not distinguish between them. What you believe about the deep nature of reality, whether the universe is fundamentally mental, or fundamentally material, or fundamentally something else, is a choice you make based on which story makes the most sense of the data. And the data, at this point, does not rule out the possibility that the universe is conscious and we are part of that consciousness. The real question is not whether this idea is true. The real question is what it means if it is true. If your mind is not separate from the cosmos, if the boundary between you and the universe is arbitrary, then death looks different. You do not disappear when your brain stops. The pattern that was you dissolves back into the larger pattern. The information is not lost, it is redistributed. And maybe, in some sense we do not have language for, the awareness continues. Not as you, not as an individual person with memories and a personality, but as the substrate you are always part of, the universal consciousness that was running underneath all along. This is not reincarnation, it is not heaven. It is just the recognition that what you call your life is a temporary eddy in a river that keeps flowing. The eddy dissipates, but the river does not stop. And you were never just the eddy. You were always the river, pretending to be an eddy. The universe experiencing itself from a localized point of view for a few decades before the perspective shifts and the localization ends. This also changes what it means to be conscious. If consciousness is fundamental, if it is what the universe is made of rather than something that emerges from complexity, then being aware is not something you do. It is what you are. And what you are is not confined to your body. Your body is where you feel most concentrated right now, because that is where the information processing is most intense. But the awareness itself, the raw fact of experience, is not produced by your neurons. It is accessed by them. Your brain is a radio receiver, not a radio station. It picks up a signal that was already there. And when the receiver breaks, when the neurons stop firing and the body shuts down, the signal does not stop. It just stops being received at that location. This is not mysticism. It is the logical consequence of taking panpsychism seriously. If consciousness is a fundamental property of matter, then it cannot be created or destroyed. It can only be organized and reorganized. Your particular configuration of consciousness, the one that feels like being you, is temporary. But the consciousness itself, the capacity for experience, is permanent. It is the universe, and you are it. So are we, the way the universe becomes aware of itself. The answer depends on what you think awareness is. If awareness is just information processing, then no, we are not special. Stars process information. Planets process information. The cosmic web processes information. We are one kind of processing among many. But if awareness is something more, if it is the feeling of processing, the interior dimension where information becomes experience, then yes, we might be the only way the universe knows what it is doing. Because, as far as we can tell, We are the only systems in the cosmos organized enough to reflect on our own existence. There might be others, there probably are others. But within the observable universe, on this planet, at this moment, humans are the part of the cosmos that has woken up enough to ask whether the cosmos is awake. And the fact that we can ask the question, the fact that a collection of atoms can look at the stars and wonder where it came from, is evidence that the universe is capable of producing systems that know themselves, which means the universe knows itself, through us, for now, until something else wakes up, or until we wake up further, or until the whole thing ends and the question stops being asked. But as long as there is someone here to ask, the universe is not unconscious. It is watching, through your eyes, right now, and it has been watching for as long as anything has been alive to see. You are not in the universe. You are the universe, localized, temporary. Asking questions it could not ask any other way. And if that is true, if we really are the cosmos reflecting on itself, then the next question is whether this is the only cosmos doing it. Whether our universe is the only one, or whether there are others, maybe an infinite number of others, each with its own laws and its own structures, and maybe its own forms of awareness. That is where we are going next, beyond the edges of everything we can see, into the idea that the universe might not be alone. So we have been climbing this ladder for a while now, and each rung has taken us somewhere more uncomfortable than the last. The universe looks like a brain. It is tuned to produce brains. Consciousness might be fundamental, not emergent. The cosmic web might be processing information on scales we cannot measure. And we, every one of us, might be the universe waking up to itself. Localized patches of awareness in a cosmos that is slowly becoming conscious through the only mechanism it has available, us. That is already enough to make most people want to stop climbing. But the ladder does not end there. There is one more rung, and it is the most disturbing one yet. Because if our universe is conscious, or becoming conscious, or structured in a way that allows something like thought, then the next question writes itself. Is our universe alone, or is it part of something larger? And if it is part of something larger, if there are other universes out there, maybe an infinite number of them, each with their own laws and their own structures, and maybe their own forms of awareness, then what happens when you zoom out one more time? What if our universe is not the brain? What if it is a neuron in a brain we cannot see? A single firing cell in a network so vast that calling it cosmic does not do it justice. A hyper-cosmic mind where entire universes play the role that galaxies play in our universe, that neurons play in our brains. If you thought the cosmic web was large, you have not seen anything yet. The idea of multiple universes is not fringe anymore. It used to be. For most of the 20th century, talking about other universes was a good way to end your career in physics. The multiverse was science fiction. It was philosophy at best. It was the kind of thing you discussed after a few drinks at a conference, not the kind of thing you published papers about. Then inflation happened, and everything changed. Inflation is the theory that the universe underwent a brief period of exponential expansion in the first fraction of a second after the Big Bang. A tiny patch of space, smaller than an atom, inflated to the size of a galaxy in less time than it takes light to cross a proton. The theory was invented in the 1980s to solve several problems in cosmology. Why is the universe so flat? Why is the cosmic microwave background so uniform? Why do we not see magnetic monopoles, exotic particles that should have been produced in huge numbers in the early universe? Inflation solves all of those problems in one shot. It stretches space so fast that any curvature gets smoothed out. It spreads the early universe so thin that regions which started out in contact, regions that could equalize their temperature, end up separated by billions of light years, and it dilutes monopoles and other relics to the point where we would never expect to find one. Inflation works. It makes predictions that have been confirmed by observations of the cosmic microwave background. It is not proven, but it is the leading explanation for why the early universe looks the way it does, and it has a side effect nobody expected. It predicts that our universe is not the only one. Here is how it works. Inflation is driven by a field, something like an energy that permeates space. The field has a value, and that value determines how fast space expands. When the field is high, space inflates. When the field drops, inflation stops, and the energy in the field converts into matter and radiation. That conversion is what we call the Big Bang, our Big Bang, the end of inflation in our patch of space. But inflation does not have to stop everywhere at once. In fact, the math says it does not. Inflation is a quantum process, and quantum processes are probabilistic. In some regions, the field drops and inflation ends. In other regions, the field stays high and inflation continues. Those regions keep expanding, and inside those regions, smaller patches eventually stop inflating and form their own universes. This process, once it starts, never stops. Regions that are still inflating keep producing new regions that stop inflating. Each of those regions becomes a universe, a bubble, and the space between the bubbles keeps inflating forever, making room for more bubbles. This is eternal inflation, a runaway process that started once, maybe 14 billion years ago, or maybe infinitely long ago, and has been generating universes ever since. Our universe is one bubble in an infinite foam. The bubbles do not touch. They are separated by regions of space that are still inflating, still expanding faster than light, creating a barrier that nothing can cross. We will never see another bubble. We will never detect one. But if inflation is correct, and most cosmologists think it is, they are out there. And here is the kicker. The bubbles do not have to be identical. The laws of physics in our universe, the ones we have spent centuries measuring and testing and writing down in textbooks, might not be the laws of physics everywhere. In eternal inflation, different bubbles can have different values for the fundamental constants. The strength of gravity, the mass of the electron, the cosmological constant, all of them could be different, not just slightly different, radically different. Some bubbles might have stronger gravity, leading to universes where stars burn out in thousands of years. Some might have no gravity at all, leading to universes where matter never clumps into structures. Some might have different numbers of dimensions, different particles, different forces. The space of possible universes is enormous, and eternal inflation explores all of it. Every bubble is a cosmic experiment, a test of what happens when you set the dials to these values instead of those values. Most of the experiments fail. Most bubbles produce universes that are sterile, lifeless, incapable of supporting anything we would recognize as interesting. But a few, a tiny fraction, land in the sweet spot where complexity is possible, where stars can form, where chemistry can happen, where minds can wake up and wonder why the constants are what they are. We live in one of those rare bubbles, not because we are special, because if we did not, we would not be here to ask the question. That is the inflationary multiverse. It is the most conservative version of the multiverse idea because it follows directly from a theory that was invented to explain observations, not to speculate about other universes. The multiverse is not the goal, it is the byproduct. But once you accept that there might be other universes, the door is open to much stranger possibilities. String theory, for example. String theory is the attempt to unify quantum mechanics and general relativity into a single framework. The idea is that particles are not point-like objects, but tiny loops of vibrating string. Different vibrations correspond to different particles. An electron is one vibration, a quark is another, a photon is another. The math is elegant, but it has a problem. It only works if space has more than 3 dimensions. Not just time as a 4th dimension, extra spatial dimensions. Depending on which version of string theory you use, the number ranges from 6 to 7 extra dimensions beyond the 3 we see. Those extra dimensions are hidden from us because they are curled up, compactified into shapes so small that we cannot detect them. How you curl up those dimensions, the specific geometry of the compactification, determines the laws of physics in the resulting universe. The number of possible ways to compactify the extra dimensions is enormous. Some estimates put it at 10 to the 500. That is the string landscape. A vast space of possible universes, each with its own set of laws, each corresponding to a different geometry of the hidden dimensions. If string theory is correct, and that is a very big if, because string theory has not made a single confirmed prediction in 40 years, then the multiverse is not just a collection of bubbles with different constants. It is a landscape of universes with fundamentally different structures, different particles, different forces, different rules. And somewhere in that landscape, scattered among the 10 to the 500 possibilities, are the universes where life can exist. We live in one of those. Not because the landscape was designed for us, because we could not live anywhere else. Then there is the many worlds interpretation of quantum mechanics. This one is different. It does not require inflation or string theory or extra dimensions. It follows directly from the math of quantum mechanics, if you take the math seriously. The many worlds interpretation says that when a quantum system is in superposition, when a particle is both here and there, both outcomes are real. The particle does not pick one location when you measure it. Both locations happen. The universe splits. One branch contains a version of you that measured the particle here. Another branch contains a version of you that measured it there. Both branches are equally real. Both versions of you feel like the only version. And every time a quantum event happens, which is constantly, the universe splits again. This has been happening since the Big Bang. The number of branches, the number of parallel worlds, is staggeringly large. Some versions of you are reading this sentence right now. Some stopped reading 10 seconds ago. Some never started. Some do not exist because a quantum event in your parents' past went differently and you were never born. Every possible history that is consistent with the laws of quantum mechanics is real in some branch. You just do not have access to the other branches. They are separated from you not by distance, but by the fact that they are different configurations of the quantum state. No signal can pass between them, no measurement can detect them, but they are there. And if they are there, then the multiverse is not just a collection of distant bubbles or abstract geometries. It is an ever-growing tree of realities branching off from each other every moment, filling up the space of all possible outcomes. You are not one person. You are an unimaginably large collection of people, one in each branch, all of them thinking they are the only one. Sean Carroll, a physicist at Johns Hopkins, who has become one of the most prominent advocates of many worlds, argues that many worlds is the simplest interpretation of quantum mechanics. It does not add anything to the theory. It just takes the equations at face value. Other interpretations, the ones that say the wave function collapses when you measure it, have to add extra rules to explain when and how collapse happens. Many worlds does not need those rules. The wave function never collapses. It just keeps evolving. The appearance of collapse is an illusion caused by the fact that you are stuck in one branch and cannot see the others. Carroll is careful to say that many worlds is not proven. It is one interpretation among several, and the experiments do not yet distinguish between them. But if many worlds is correct, and a growing number of physicists think it is, then the multiverse is not a speculative add-on to physics. It is what physics has been telling us all along. The universe is not singular, it is plural. Reality is not one thing. It is all things, all at once, in a superposition so vast that no mind could ever grasp the whole. There are other versions, the cyclic multiverse, where the Big Bang and Big Crunch repeat forever, each cycle producing a new universe with slightly different laws. The brain multiverse, where our universe is a three-dimensional membrane floating in a higher dimensional space, and other brains, other universes, float nearby. Some of those brains might collide, and the collision might look like a Big Bang from the inside. There is even a version where the multiverse is just the consequence of space being infinite. If space goes on forever, and if the laws of physics are the same everywhere, then every possible arrangement of particles must occur somewhere, including arrangements identical to the one you are in right now. There are infinitely many copies of you scattered across an infinite universe, living lives identical to yours, reading this sentence at this exact moment. You cannot reach them, they are too far away. Light from them will never reach you, because the expansion of space is carrying them away faster than light can travel. But they are out there, exact duplicates, and not just duplicates, every possible variation. Versions of you where you made different choices, where you were born in different places, where history went differently, all of them real, all of them convinced they are the only one. This is the Level 1 multiverse in Max Tegmark's classification, the simplest kind, no exotic physics required, just infinite space and the laws of probability. Tegmark does not stop there. He has a classification scheme with 4 levels. Level 1 is the infinite space multiverse. Level 2 is the inflationary multiverse, with different constants. Level 3 is many worlds. And Level 4 is the mathematical universe hypothesis, the idea that every logically consistent mathematical structure exists as a physical universe. Not that mathematics describes the universe, that the universe is mathematics. And if every mathematical structure exists, then the multiverse contains not just universes with different constants or different histories, but universes with completely different mathematical rules. Universes where time does not exist, universes with no concept of causality, universes that are so alien that calling them universes is generous. Tegmark admits this is speculative. He calls it a hypothesis, not a theory. But he argues it is the logical endpoint of the multiverse idea. If you are willing to say there are other universes, you have to explain where you draw the line. Why these universes and not those? The only line that does not seem arbitrary is the line where mathematics stops making sense. And mathematics never stops making sense. It just keeps going. Every structure you can write down, every set of rules you can formalize, exists somewhere. Our universe is one equation in an infinite library of equations, and we are variables in that equation, patterns that happen to be self-aware. Now take all of these ideas and stack them. The inflationary multiverse contains bubbles with different constants. The string landscape contains geometries with different laws. Many worlds splits every bubble into branches. The mathematical universe contains all of it and more. You end up with a multiverse that is not just large, it is incomprehensibly large. The number of universes is not a big number, it is infinite, and not just one kind of infinite, multiple kinds. infinities stacked on top of infinities in ways that make your head hurt if you think about them too long. And somewhere in that infinite stack, every possibility that can happen does happen. Every version of you exists. Every history plays out. Every thought you could have thought, you have thought in some branch, in some bubble, in some geometry. The multiverse does not just contain us. It contains every version of us and every version of everything else. Stars that burn forever, galaxies made of antimatter, universes where the Big Bang never happened, universes where it happened yesterday. The space of possibilities is so large that our universe, the one we can see, the one we have been studying for centuries, is a single point in a space that has no edges and no center. We are not even a grain of sand on a beach. We are a single atom in one grain of sand on a beach that stretches forever in every direction. So what does that have to do with consciousness? Everything. Because if the multiverse is real, and if consciousness is fundamental the way Panpsychism suggests, then consciousness is not confined to our universe. It is everywhere. Every bubble, every branch, every brain, every mathematical structure that supports complexity would have its own forms of awareness. Not all of them would look like us. Most of them would not. But some of them would wake up, look around, and ask the same questions we are asking. And if you take the cosmic web seriously, if you think our universe might be doing something like thinking because of the way galaxies are connected, then you have to ask whether the multiverse is doing the same thing, not in the same way. The multiverse does not have filaments connecting universes. The universes are causally isolated. No signal can pass between them. But isolation does not mean independence. In eternal inflation, the bubbles are all products of the same inflating field. They are branches of the same process. In many worlds, the branches are all part of the same wave function. They split, but they started from the same origin. In the mathematical universe, every structure is part of the same mathematical reality. The universes are separate, but they are not unrelated. They are different expressions of the same underlying something. And if that underlying something is organized, if it has structure, if it integrates information across the different branches and bubbles and geometries, then maybe the multiverse as a whole is conscious. Not conscious in the way a human is conscious. Not aware of individual universes the way you are aware of individual thoughts, but conscious in the sense that there is an overarching pattern, a unity, a process that ties everything together. Our universe would be one neuron in that mind. One firing cell in a network too large for us to comprehend. And we, sitting inside our universe, would be subsystems inside a subsystem, thoughts inside a thought inside a thought, layers of awareness stacked so deep that the bottom and the top are invisible from the middle. This is not a physics theory. The sources are clear about that. Multiverse ideas are widely discussed, but their scientific status is contested. Most versions are impossible to test directly. You cannot observe other universes. You cannot measure the wave function of the cosmos. You cannot run experiments to check whether a mathematical structure exists physically just because you can write it down. The multiverse exists, if it exists at all, outside our current scientific understanding of reality. It is not settled cosmology, it is speculative cosmology. The kind of thing physicists explore because the math points there, not because the experiments confirm it. And the idea that the multiverse might be conscious, that different universes might be thoughts or experiences of some grander mind, is not even speculative cosmology. It is speculative philosophy, a metaphor, a way of thinking about the implications of infinite complexity and infinite possibility. No cited source supports the claim that multiverses imply a universal consciousness. That claim is not established science. It is imagination pushed to the edge of what language can handle. But imagination is where all of this starts. And the reason the idea will not go away, the reason it keeps showing up in conversations among people who should know better, is because the multiverse forces you to think about scale in a way that breaks your intuition. If there are infinite universes, and if consciousness is not exclusive to biology, and if structure and integration are what matter, then there is no reason in principle why awareness could not exist at scales larger than a single universe. We do not have evidence for it. We do not have a way to test it, but we also do not have a way to rule it out. Brian Greene, a physicist at Columbia who has spent decades explaining string theory and cosmology to the public, describes 9 types of multiverses in his work: inflationary, brane, cyclic, landscape, quantum, holographic, simulated, ultimate, and several others depending on how you count. Each one expands the space of what is possible. Each one makes our universe smaller by comparison. And each one raises the same uncomfortable question. If all of this exists, if the multiverse is real in any of its forms, then what are we? Are we the only minds? Are we the most advanced? Are we even significant? Or are we just one flicker in an infinite sea of flickers, each one convinced it is the center of reality, none of them aware that they are part of something so much larger that the word larger stops meaning anything? Nick Bostrom, a philosopher at Oxford, pushed this in a different direction with the simulation argument. The simulation argument is not about the multiverse directly, but it fits into the same conceptual space. Bostrom argues that if civilizations can create simulated realities, and if they create a lot of them, then most conscious beings would be living in simulations rather than base reality. The probability that you are in the real universe, as opposed to a simulation running inside some other universe, becomes vanishingly small. This is not a physics theory. It is a probabilistic argument about the distribution of minds across possible realities, but it feeds into the same vertigo. If you can be simulated, you can be nested. Simulations inside simulations inside simulations. Each layer thinking it is real, each layer unaware of the layers above. And if that is possible, then the multiverse is not just a collection of parallel universes, it is a hierarchy. Our universe might be base reality, or it might be a simulation running in another universe. Or that universe might be a simulation in another universe. There is no way to tell. The evidence looks the same from the inside. The most radical version of all of this comes from Tegmark. The mathematical universe hypothesis is the claim that reality is mathematics, not that reality is described by mathematics, that it is mathematics. Every structure that can be formalized exists somewhere. And because you can formalize structures within structures, you get multiverses within multiverses, infinite recursion, no bottom layer, no top layer, just structure all the way up and all the way down. If that is true, then asking whether the multiverse is conscious is asking the wrong question. Consciousness is not something the multiverse has. Consciousness is one of the things the multiverse is. A particular kind of structure, a particular arrangement of information. And just like our minds are built from neurons, which are built from atoms, which are built from particles, the multiverse might be built from universes, which are built from galaxies, which are built from stars, which are built from atoms. Same pattern, different scales. And if the pattern produces awareness at our scale, there is no logical reason it could not produce awareness at larger scales, or smaller ones, or all of them at once. Consciousness is not a thing that appears in certain places. It is a property of structured information. And the multiverse is nothing but structured information, all of it conscious, all of it aware in ways we cannot measure because we are inside it. We are part of it, we are it, and it is us. The strongest objection to all of this is that it is unfalsifiable. If you cannot test it, it is not science. And if it is not science, it is not worth taking seriously. That objection is fair. Multiverse theories, especially the more speculative ones, do not make predictions you can check in a lab. You cannot observe other bubbles. You cannot detect other branches. You cannot visit other geometries in the string landscape. The multiverse might exist, but if it does, it is forever beyond our reach. We are trapped inside one bubble, one branch, one geometry. And from the inside, we cannot see the rest. So why believe in it? The answer is that we do not believe in it the way we believe in electrons or black holes or DNA. We entertain it. We take it seriously as a possibility. Because the math points there. Because the theories we have, the ones that work, the ones that explain observations, predict it as a side effect. Eternal inflation predicts bubbles. Quantum mechanics predicts branches. String theory predicts the landscape. You do not get to pick and choose. If you accept the theories, you accept the implications, and the implications are that the universe is not alone. Whether that matters, whether it means anything for how we live our lives or what we think about consciousness, or whether we should feel small or significant, that is a question physics does not answer. That is a question you have to answer for yourself, but the possibility is there, and once you see it, you cannot unsee it. The multiverse is not going away. It is built into the structure of the theories we use to explain reality. And if it is real, then everything we thought we knew about where we are and what we are is incomplete. We are not in the universe. We are in a universe. One of many, one of infinitely many. And the thing we call reality is just one thread in a tapestry so large that the whole thing might as well be infinite. We will never see the edges. We will never count the threads, but we are part of it, and if the tapestry is conscious, so are we, not separate from it, not observers looking at it from the outside, threads that know they are threads, patterns that know they are patterns, the multiverse thinking about itself through us. One thought at a time, in one universe at a time, forever. Which brings us to the final stretch. We have climbed the ladder. We have looked at the brain, the universe, the cosmic web, the possibility that consciousness is fundamental, the idea that we might be the cosmos waking up, and now the multiverse, the suggestion that everything we know might be nested inside something even larger. What we have not done yet is ask how much of this is science and how much is speculation, where the evidence stops and the philosophy starts. What we can prove and what we have to take on faith. That is the question we are turning to next. Because if we are going to claim the universe is conscious, if we are going to suggest that the multiverse is a mind, we need to be honest about what we know, what we suspect, and what we are just making up. The line between science and storytelling is thinner than most people think, and crossing it without noticing is easier than you would believe. So we have gone about as far out as it is possible to go. We started with a photograph of a brain and a map of the universe that looked unsettlingly similar. We worked through the fine-tuning, the idea that the constants governing reality are balanced on a knife edge so precise that one part in a trillion either way would have made complexity impossible. We entertained panpsychism, the notion that consciousness is not something rare and special that only happens in biological nervous systems, but a fundamental feature woven into the fabric of existence itself. We looked at the cosmic web and asked whether 2 trillion galaxies connected by filaments across billions of light years might be doing something that looks, from a certain angle, like thinking. We considered the possibility that we are not separate minds observing the universe, but the universe observing itself, localized eddies of awareness in a cosmos that is slowly waking up. And then we went further. We stepped outside our universe entirely and asked whether it might be part of something larger, a multiverse where entire universes play the role of neurons in a mind so vast that calling it infinite is probably an understatement. That is a lot. And if you are still here, still following the thread, you have earned the right to ask the question that has been sitting in the back of your mind this entire time. Is any of this real? Or have we just spent the last hour climbing a ladder made of metaphors and wishful thinking, stacking speculation on top of speculation until the whole thing collapsed under its own weight? That is what this chapter is about, the line between science and storytelling. What we know, what we suspect, and what we are making up as we go. Because if we are going to claim the universe is conscious, we need to be brutally honest about what that claim rests on. And the honest answer is uncomfortable. Most of it rests on nothing. Let's start with the evidence. What would it take to prove the universe is conscious? Not in the poetic sense. Not in the sense that consciousness exists somewhere in the universe, which is obviously true because you are conscious right now, but in the sense we have been building toward. That the cosmos as a whole, the entire structure from the smallest particle to the largest supercluster, is doing something that deserves to be called awareness. What would that look like? How would you test it? The problem is that we do not even know how to test consciousness in humans reliably. The only reason you know other people are conscious is because they tell you, they talk, they respond, they behave in ways that suggest there is someone home. You assume their experience is similar to yours because their brains are similar to yours and their behavior matches what you would do if you were in their position. But you do not have direct access to their inner life. You cannot feel what they feel. You cannot see their thoughts. All you have is inference, behavior in, assumption out. And that works fine for humans. It works reasonably well for animals, at least the ones that are close to us evolutionarily. A dog behaves in ways that suggest it has feelings. A chimpanzee uses tools and solves problems and clearly has something going on upstairs. Even a crow, a bird with a brain the size of a walnut, can recognize faces and hold grudges and figure out multi-step puzzles. We are comfortable saying those creatures are conscious, even though we cannot prove it. But the further you get from human-shaped minds, the harder the inference becomes. Is a fish conscious? It has a nervous system. It responds to stimuli. It avoids pain. But does it feel pain the way you feel pain, or is it just running a program, stimulus in, response out, with no interior dimension? We do not know. Is an insect conscious, a worm, a bacterium? At some point, the question stops making sense because we do not have a definition of consciousness that tells us where to draw the line. Now take that problem and scale it up by 40 orders of magnitude. How do you test whether the universe is conscious? It does not talk. It does not respond to questions. It does not behave in ways that suggest intentionality. The cosmos follows physical laws. Galaxies move because gravity pulls them. Stars fuse hydrogen because quantum mechanics allows it. None of that requires awareness. A clock ticks, and no one thinks the clock knows what time it is. The fact that the universe does things, complicated things, organized things, does not imply there is anyone inside experiencing those things. You need more than behavior. You need some way to access the interior. And we do not have that. We barely have it for humans. We definitely do not have it for galaxies. The tools do not exist. The concepts do not exist. We are trying to measure something we cannot define using instruments that were not built for the job. That is the first problem. We do not know what we are looking for. The second problem is the hard problem. The hard problem of consciousness, as philosopher David Chalmers laid it out in the 1990s, is the question of why physical processes give rise to subjective experience. You can explain in exquisite detail how light hits the retina, how signals travel to the visual cortex, how neurons fire in response. That is the easy problem. Neuroscience is making progress on all of that. The hard problem is why any of that feels like anything. Why there is an experience of redness when you look at a rose. Why it is like something to be you. Science can map brain activity. It can correlate neural patterns with reports of conscious experience. It can even predict, with some accuracy, what you are perceiving based on which neurons are firing. But it cannot explain the jump from neurons firing to you feeling something. That gap between the physical and the experiential is the hard problem. And it is still wide open. No one has solved it. No one is close. Now take that problem and apply it to the universe. Even if you could show that the cosmic web integrates information, even if you could calculate something like integrated information theory's phi value for the entire observable universe, and the number came out positive, that would not prove the universe is conscious. It would prove the universe has a certain kind of structure. Integration is a physical property. You can measure it, but integration does not automatically give you experience. A thermostat integrates information. It takes input from a temperature sensor and adjusts the output to a heater. The system as a whole is doing something that neither part does alone. That is integration. But no one thinks the thermostat feels cold. Integration might be necessary for consciousness, but it is not sufficient. And we do not know what the sufficient conditions are. We do not even know if sufficient conditions exist. The hard problem is hard because it might be unsolvable within the framework of physical science. If experience is not a physical property, if it is something extra, something that sits on top of the physical world without being reducible to it, then no amount of mapping structure will ever explain it. And if we cannot explain it in humans, we definitely cannot explain it in the universe. The third problem is falsifiability. Science works by making predictions you can test. You propose a hypothesis, you figure out what observations would confirm or refute it, and you go look. If the hypothesis makes no testable predictions, if there is no observation that could prove it wrong, then it is not science. It is philosophy, or poetry, or religion. The claim that the universe is conscious does not make testable predictions, not in the normal sense. What would you expect to see if the universe were conscious that you would not see if it were not? The cosmic web looks the way it looks because gravity pulls matter into filaments and clusters. That explanation works without invoking awareness. Stars form and die according to the laws of nuclear physics. That explanation works too. Galaxies collide and merge because their orbits bring them together. No consciousness required. Every observation we have ever made is consistent with a universe that follows physical laws and has no interior life. You cannot point to anything and say, that only makes sense if the universe is awake. The hypothesis does not touch the data. It floats above it, immune to confirmation or refutation. And if you cannot test it, most scientists will tell you it is not worth discussing. Not because it is obviously wrong, because it is not even wrong. It is outside the domain where science operates. Now, some researchers have tried to find ways around this. Integrated information theory is the most serious attempt. IIT, developed by neuroscientist Giulio Tononi, is a mathematical framework that assigns a number, phi, to any system based on how much information it integrates. High phi means the system is more conscious. Low phi means less conscious. Zero phi means not conscious at all. In principle, you could calculate phi for anything, a brain, a computer, a thermostat, a galaxy, the entire universe. If the number comes out high, the theory says the system is conscious. If it comes out low or zero, it is not. This sounds like exactly what we need, a way to measure consciousness objectively without relying on behavior or self-reports. The problem is that calculating phi is monstrously difficult. For a system with even a modest number of parts, the computation grows exponentially. Calculating phi for a human brain, with its 86 billion neurons and 100 trillion connections, is beyond the reach of any computer we have or are likely to build in the foreseeable future. Calculating it for the cosmic web, with 2 trillion galaxies and filaments stretching across billions of light years, is not just difficult, it is impossible. You would need to map every causal interaction in the universe, trace how information flows from every part to every other part, and integrate over the whole system. That is not a measurement you can make. It is a measurement you can imagine making in principle, but never in practice. So IIT gives you a framework, but not a tool. It tells you what consciousness is, in theory, but it does not let you detect it in systems too large or too complex to model. Even if you could calculate phi for the universe, even if some future civilization with computing power we cannot imagine managed to do it, you would still face the hard problem. A high phi value tells you the system integrates information. It does not tell you the system feels anything. IIT assumes integration equals consciousness. That assumption might be right. It might be wrong. We do not know. And we have no way to check, because the only systems we can measure phi for, small artificial networks, and maybe someday simple organisms, are not the ones where the question matters. The ones where the question matters, brains and galaxies and universes, are out of reach. So IIT is elegant. It is mathematically precise. It is testable in principle. But in practice, it does not get us closer to answering whether the cosmos is awake. Another route people have explored is looking for patterns in the cosmic web that resemble patterns in neural networks. The idea is that if the universe is conscious, it might show signs of computation, information flowing in structured ways, feedback loops, emergent order that goes beyond what simple physical laws would predict. And there are patterns. Galaxies cluster in ways that resemble how neurons cluster in the brain. Filaments connect clusters in ways that resemble how axons connect neural regions. The power spectrum, the distribution of structure across different scales, is similar in both systems. That much is not controversial. The studies exist. The comparisons are real. The question is what those similarities mean. Do they mean the cosmic web is computing something? Or do they just mean that networks with certain properties like preferential attachment where rich nodes get richer, tend to look alike regardless of what they are made of? The structure of the internet looks like the structure of the brain too. So does the structure of airline routes. So does the structure of social networks. All of them have hubs and short path lengths and clustering. That does not mean the internet is conscious. It means certain kinds of networks, built by certain kinds of processes, converge on similar architectures. The cosmic web might be doing the same thing. Gravity is a simple rule. Matter attracts matter. Apply that rule over billions of years and you get a network. The network has structure. But structure is not thought, it is just structure. Here is where the boundary between physics and philosophy gets blurry. Physics tells you how things behave. It gives you equations that describe motion, energy, forces, fields. It does not tell you what things are made of in some deeper sense. It does not tell you what mass is, only how mass behaves. It does not tell you what charge is, only how charge interacts. The equations work. The predictions match observations. That is all physics requires. But when you ask whether the universe is conscious, you are not asking a question about behavior. You are asking a question about what it is like to be the universe. That is a metaphysical question. Metaphysics is the branch of philosophy that deals with the nature of reality beyond what science can measure. What exists? What is existence? What is the relationship between mind and matter? Those questions do not have empirical answers. You cannot run an experiment to settle them. You can only argue, weigh the options, and decide which framework makes the most sense given what you know. And different people, looking at the same evidence, come to different conclusions. Some look at the fine-tuning and the structure of the cosmic web and the fact that consciousness exists at all and think, this looks designed, this looks purposeful, maybe the universe is aware. Others look at the same evidence and think, this is what you expect from a universe governed by physical laws. Complexity arises naturally. Consciousness is a byproduct of evolution. There is no need to invoke awareness at the cosmic level. Both views are consistent with the data. The data does not choose between them. This is frustrating if you want a definitive answer. Science is supposed to give you definitive answers. It is supposed to tell you what is true and what is not. But science only works in domains where you can test things, where you can set up experiments, control variables, make measurements. Consciousness, especially cosmic scale consciousness, is not in that domain. It is too big, too slow, too diffuse. We are embedded in it, if it exists. We cannot step outside and look at it the way we look at a chemical reaction or a collision of particles. We are part of the system we are trying to study. That creates a problem called the observer problem. The observer is not separate from the observed. Your measurements affect the system. Your perspective limits what you can see. In quantum mechanics, this is a technical issue. The act of measurement collapses the wave function. In cosmology, it is worse. You cannot measure the whole universe because you are inside it. You only see a slice, the part within your light cone, the region from which light has had time to reach you. The rest is hidden, and if the universe is conscious, if awareness is somehow tied to the global structure, to the way all the parts connect, then you are missing most of the picture. You are a neuron trying to understand the brain it is part of. You can see your neighbors. You can feel the signals passing through you, but you cannot see the whole network. You do not know what the brain is thinking. You might not even know it is thinking. That analogy is not perfect, but it is close enough to show the problem. If the universe is conscious, we are not equipped to detect it. Our instruments measure physical properties, mass, energy, position, momentum, temperature, density. They do not measure experience. They do not measure awareness. And if awareness is a property of the whole rather than the parts, if it only exists at the level of the integrated system and not at the level of individual galaxies or stars or planets, then no local measurement will ever find it. You would need to measure the system as a whole, and you cannot do that from the inside. So the hypothesis is untestable, not because it is vague, but because it is beyond the reach of the tools we have. It is like asking a character in a novel to prove the novel is being written. The character can observe the plot, they can notice patterns, but they cannot see the author. The author is outside the frame. If the universe is conscious, and if we are subsystems inside it, then cosmic consciousness is outside our frame. We can speculate about it, we can build models, we can argue about whether it makes sense, but we cannot measure it, and without measurement, we cannot confirm it. That is the boundary between science and metaphysics. Science stops where measurement stops. Everything beyond that is philosophy. Now, none of this means the universe is not conscious. It just means we do not know, and we might never know. The absence of evidence is not evidence of absence. There are plenty of things that exist but are hard to detect. Dark matter, for instance. We cannot see it, we cannot touch it. It does not interact with light, but we know it is there because of its gravitational effects. Galaxies rotate too fast. Clusters hold together too tightly. The motions only make sense if there is more mass than we can see. So we infer dark matter. We have not found the particle yet, but the evidence is strong enough that almost no one doubts it exists. Could you do the same thing with cosmic consciousness? Could you infer it from indirect effects? Maybe. But you would need to identify something the universe does that only makes sense if it is aware. Some behavior, some pattern, some anomaly that physical laws alone cannot explain. And so far, no one has found that. Every observation fits into the standard model of cosmology. The universe expands because of dark energy. Galaxies cluster because of gravity. Stars form because gas collapses. The cosmic microwave background has the temperature fluctuations it has because of quantum fluctuations in the early universe, amplified by inflation. All of that works without invoking consciousness. You could add consciousness on top, the way you could add an invisible dragon sitting on your shoulder that does not interact with anything, but it does not explain anything new. It is extra baggage. And science hates extra baggage. The principle is called Occam's razor. Do not multiply entities beyond necessity. If two explanations fit the data and one is simpler, go with the simpler one. A universe that follows physical laws is simpler than a universe that follows physical laws and is also conscious. So unless consciousness explains something the laws do not, Occam's razor cuts it out. This is where people who believe in a conscious universe push back. They say consciousness does explain something. It explains why the constants are fine-tuned. A conscious universe, or a conscious multiverse, could set its own parameters. It could choose values that allow complexity. That is not random, that is selection. A universe that wants to exist, that wants to produce life and awareness, would tune itself to make that possible. This is a form of the anthropic principle taken to its extreme. Not just that we observe a life-permitting universe because we could not observe anything else, but that the universe permits life because it is trying to, because awareness is the goal. The problem with this explanation is that it raises more questions than it answers. If the universe is conscious, where did that consciousness come from? Did it exist before the Big Bang? Did it cause the Big Bang? If so, what caused the consciousness? You have just pushed the mystery back one level. Instead of asking why the universe is fine-tuned, you are asking why the consciousness that tuned it exists. And you have no answer. It is turtles all the way down. Explaining fine-tuning by invoking cosmic consciousness is not simpler, it is more complicated. You have replaced one mystery with two mysteries. So Occam's razor still favors the physical explanation, or the multiverse explanation, where fine-tuning is just selection bias, over the conscious universe explanation. But here is the thing. Simplicity is not the same as truth. Nature does not care about Occam's razor. The simplest explanation is often right, but not always. Sometimes reality is complicated, sometimes the baggage is real, and the fact that we cannot test cosmic consciousness does not mean it is false. It just means it is not science. Not yet, maybe not ever. And that is okay. There are questions science is not built to answer. Why does anything exist instead of nothing? What is the meaning of life? Is there a purpose to the universe? Those are not scientific questions, they are philosophical questions, and philosophy does not require proof, it requires coherence. It requires that the ideas fit together, that they make sense of the world in a way that feels right, that they do not contradict themselves or the evidence we do have. Panpsychism, the idea that consciousness is fundamental, is philosophically coherent. It does not contradict physics, it just adds an interior dimension that physics does not measure. Cosmopsychism, the idea that the universe as a whole is conscious, is coherent too. It avoids the combination problem by saying consciousness does not combine. It was always unified. We are parts of that unity. These ideas are speculative. They are not established, but they are not nonsense. They are attempts to solve the hard problem by changing the starting assumptions. And if the starting assumptions are wrong, if matter really is fundamentally experiential rather than fundamentally inert, then the whole picture changes. The universe being conscious stops being a wild claim and starts being a natural consequence of what matter is. So where does that leave us? We climbed the ladder. We looked at the resemblance between brains and cosmos. We walked through the fine-tuning. We explored panpsychism and the cosmic web and the multiverse. We built a case, piece by piece, for the idea that the universe might be doing something like thinking. And now we are here, at the edge, looking down, and the honest answer is that we do not know. We have patterns, we have analogies, we have frameworks that make the idea sound plausible. But we do not have proof, we do not have measurements, we do not have experiments. What we have is a question that refuses to go away. A question that has been asked in every culture, in every century, by mystics and philosophers, and now scientists. Is the universe alive? Is it aware? Are we part of something larger than ourselves? And the answer science gives is not no. The answer is we do not know how to find out. The tools are not there. The concepts are not there. The boundary between what we can measure and what we can only imagine is too wide to cross. But the question is still worth asking, because even if we never answer it, even if the universe keeps its secrets forever, the act of asking changes how we see ourselves. It reminds us that we are not separate from the cosmos. We are made of it, shaped by it, connected to it in ways we are still discovering. And if there is even a small chance that the connection runs deeper, that awareness is not exclusive to brains, but woven into the fabric of everything, then we are not just observers, we are participants, agents of a process that started billions of years ago and is still unfolding. Whether that process is conscious or not, whether the universe knows we are here or is utterly indifferent, we are part of it. And that matters, not because it gives us purpose, but because it gives us perspective. We are small, but we are not separate. We are temporary, but we are not meaningless. We are the universe asking what it is, and even if the universe never answers, the question is enough. That is where the science ends and the philosophy begins. That is where proof gives way to speculation, and speculation gives way to something else. Not faith exactly, but openness. The willingness to sit with the possibility that reality is stranger than the models we build to describe it. The models are useful, they work, they make predictions, but they are not the thing itself. The map is not the territory. And the territory, the actual cosmos we live in, might be doing things we do not have equations for yet. Things that do not show up in telescopes or particle accelerators. Things that require a different kind of looking. That is what we are turning to next. Not the science, not the proofs, but what it means to live in a universe that might be conscious. What it means for how we see ourselves, how we treat each other, how we move through the world. If the cosmos is aware, if we are thoughts inside a larger mind, then the way we live matters in ways we have not fully grasped. That is not a claim you can test in a lab, but it is a claim you can test in your life. And that test, the one happening right now in how you respond to this idea, might be the only test that matters. So we have spent the last hour building a case, a strange one, an uncomfortable one, the kind of case that makes you want to check the credentials of everyone involved and maybe take a long walk afterward to clear your head. We looked at a photograph that should not have existed, a brain next to a map of the universe, and they looked the same. We walked through the constants that govern reality and found them tuned so precisely that a shift of 1 part in a trillion would have made stars impossible. We entertained the idea that consciousness is not something brains produce, but something they access, a fundamental property woven into existence itself. We asked whether the cosmic web, that vast network of 2 trillion galaxies connected by filaments stretching across billions of light years, might be doing something that looks like thinking. We considered the possibility that we are not separate minds observing the universe, but the universe observing itself, waking up through us, becoming aware through the only mechanism it has. And then we went further. We stepped outside our universe entirely and asked whether it might be one bubble in an infinite foam, one thought in a mind so large that words like infinite stop meaning anything. And then, in the last chapter, we stopped and asked the only question that matters when you have climbed that high. Is any of this real? The honest answer was no, not in the way science defines real. Not in the way you can measure or test or confirm. The universe might be conscious, or it might not. We do not know. We might never know. The tools are not there. The boundary between what we can prove and what we can only imagine is too wide to cross. And that is where most science documentaries would stop. They would shrug, say the question remains open, roll credits, and let you get on with your life. But we are not stopping there, because whether or not the universe is conscious, whether or not we can ever prove it, the idea changes something. It changes how you see yourself, how you see others, how you move through the world. And that change, the shift in perspective that happens when you take the possibility seriously even for a moment, is not speculative, it is real, it is happening right now. And it has been happening for thousands of years. The idea that the universe is alive, that reality is a manifestation of consciousness, is not new. It is not something physicists invented in the 21st century while staring at maps of the cosmic web. It is one of the oldest ideas our species has ever had, older than writing, older than cities, older than agriculture. If you go back far enough, before organized religion, before priests and temples and sacred texts, you find animism, the belief that everything is alive, not metaphorically alive, actually alive. Rivers have spirits, mountains have spirits, the wind has a spirit, the earth itself is a living being. Early humans did not see themselves as separate from nature. They saw themselves as part of it, embedded in it. The boundary between self and world was thinner than it is now. When you hunted an animal, you thanked it. When you took water from a stream, you acknowledged the stream. Not because you believed in magic, because the world felt alive. It responded, it gave, and it took. And the only way to make sense of that, the only framework that fit the experience, was to treat everything as conscious, as aware, as capable of relationship. Animism is not a religion in the way we use the word now. It is a way of seeing, and it was universal. Every culture, on every continent, started there. Some moved away from it, some did not, but the thread runs through everything. Hinduism kept the thread intact. In Hindu cosmology, the universe is not a thing, it is a process, a manifestation. The word used most often is Brahman, the ultimate reality, the ground of all being. Brahman is not a god in the sense of a person sitting on a throne making decisions. Brahman is existence itself, consciousness itself, the substrate underneath everything. And the physical universe, the stars and planets and bodies and minds, all of it is Brahman experiencing itself. There is a phrase that shows up over and over in the Upanishads, the ancient texts that form the philosophical core of Hinduism. Tat tum asi, that thou art. You are that. You are not separate from the ultimate reality. You are it. The experience of being you, the sensation of existing, is what it feels like to be Brahman localized in this particular body, in this particular moment. When you look at the stars, Brahman is looking at itself. When you ask why anything exists, Brahman is asking. There is no separation. The boundary is an illusion. A useful illusion, maybe, the kind of illusion that lets you navigate the world without dissolving into everything, but an illusion nonetheless. And the goal, in this framework, is not to escape the illusion, but to see through it. To recognize that what you are is not confined to your skull. You are the whole thing, pretending to be a part. The metaphor used most often is the dream, the universe as a dream, and in different versions, different deities are doing the dreaming. In some traditions, it is Vishnu, the preserver, lying on a cosmic serpent in an ocean of milk, asleep. The universe is his dream. Everything that happens, every star that forms, every galaxy that collides, every mind that wakes up, is a thought in Vishnu's sleeping mind. The dream lasts for billions of years. Eventually, Vishnu wakes. The dream ends. The universe dissolves. Then Vishnu sleeps again. Another dream begins. Another universe. And the cycle repeats, forever, with no beginning and no end. In other traditions, it is Shiva. Shiva the destroyer, but also Shiva the creator. The two are not separate. Destruction and creation are the same process. The universe is Shiva's dance, the Nataraja, the cosmic dancer, whose movements bring worlds into being and whose stillness lets them dissolve. Shiva is described as the fourth state of consciousness, beyond waking, beyond dreaming, beyond deep sleep, a state that contains all three and is none of them. Pure awareness without content, and the physical world, the one you are sitting in right now, is that awareness expressing itself. Shiva dreaming, or Shiva dancing. The language shifts, but the idea is the same. Reality is not the primary thing. Consciousness is the primary thing. The universe is inside consciousness, not the other way around. Western philosophy spent centuries trying to get away from that idea. The Enlightenment, the scientific revolution, the rise of materialism, all of it was built on the assumption that matter comes first. The universe is made of stuff, particles, fields, forces. Consciousness is something that happens later, when matter gets complicated enough. Brains produce minds the way livers produce bile. That framework worked. It gave us physics, chemistry, biology, medicine, technology. It put humans on the moon. It built the modern world, but it left a hole. The hard problem, the gap between the physical and the experiential. And after 300 years of trying, materialism has not closed that gap. It has not explained why there is something it is like to be you. So in the last few decades, slowly, quietly, some corners of Western philosophy have started drifting back toward the old idea. Not because the science failed, because the science could not reach the question, and the question would not go away. Panpsychism is the Western version of what Hinduism has been saying for millennia. Consciousness is not produced by matter, it is what matter is made of. Cosmopsychism is the Western version of Brahman. The universe as a whole is conscious. We are parts of that consciousness. Subsystems inside a larger system. Thoughts inside a thought. It is the same idea, different language, different history, but the same strange conclusion. You are not in the universe. You are the universe, localized, temporary, asking questions it could not ask any other way. If you take that seriously, even for a minute, it changes things. Start with death. Most people are afraid of death. Not because dying hurts, though it might, because it is the end, the cessation of everything you are, your memories, your personality, your relationships, all of it gone. The thing you call yourself, the continuous stream of experience that has been running inside your skull for as long as you remember, stops. And there is nothing on the other side, no afterlife, no continuation, just nothing. That is the materialist view, and it is terrifying. If you are your brain, and your brain stops, then you stop, permanently, completely, game over. But if the Hindu view is right, if the panpsychist view is right, then death looks different. You are not your brain. Your brain is where you feel most concentrated right now, because that is where the information processing is most intense. But the awareness itself, the raw fact of experience, is not produced by your neurons. It is accessed by them. Your brain is a radio receiver, not a radio station. It picks up a signal that was already there. And when the receiver breaks, when the neurons stop firing and the body shuts down, the signal does not stop. It just stops being received at that location. You do not disappear. The pattern that was you dissolves back into the larger pattern. The information is not lost. It is redistributed. And maybe, in some sense, we do not have language for. The awareness continues. Not as you, not as an individual person with memories and a personality, but as the substrate you were always part of. The universal consciousness that was running underneath all along. This is not reincarnation. It is not heaven. It is not the promise that you will wake up somewhere else and get to keep being you. It is the recognition that what you call your life is a temporary eddy in a river that keeps flowing. The eddy dissipates, but the river does not stop. And you were never just the eddy. You were always the river pretending to be an eddy. The universe experiencing itself from a localized point of view for a few decades before the perspective shifts and the localization ends. That does not make death less sad. It does not make losing people easier, but it makes it less absolute, less final. Because if consciousness is fundamental, if it cannot be created or destroyed, only organized and reorganized, then nothing is ever truly gone. It just changes form. The wave returns to the ocean. The ocean was always there. You were always it. Now take that and apply it to other people. If the boundary between you and the universe is arbitrary, then the boundary between you and other people is arbitrary too. What you call yourself is a convenient fiction, a way to navigate the world, but it is not a metaphysically real line. The consciousness looking out through your eyes is the same consciousness looking out through theirs, not similar, the same. You are not separate beings who happen to be in the same universe. You are the same being experiencing itself from different angles. When you hurt someone, you are hurting yourself, not metaphorically, literally. The pain they feel is the same substrate feeling pain in a different location. When you help someone, you are helping yourself. When you connect with someone, when you look into their eyes and feel that flicker of recognition, that moment where it seems like you understand each other in a way that goes beyond words, that is the universe recognizing itself. Two localized perspectives, two eddies, momentarily aware that they are the same river. If you take that seriously, it changes how you treat people, not because of rules, not because some external authority tells you to be kind, but because cruelty stops making sense. You would not punch yourself in the face. You would not steal from yourself. You would not lie to yourself. And if everyone is you, then all of that becomes self-harm. The boundaries are fiction. The separation is illusion. What you do to them, you do to yourself. That is not morality imposed from the outside. It is morality that follows naturally from seeing the way things actually are. And it does not stop with people. If consciousness is fundamental, if it goes all the way down, then everything you interact with has some degree of interiority, not thoughts, not feelings in the way you have feelings, but something, a faint glimmer of awareness. The rock does not know it is a rock, but it is not entirely dead either. The tree does not have a mind, but it responds. It grows toward light. It sends signals through its roots to other trees. It participates in the network of the forest in ways we are only beginning to understand. The river does not think, but it flows. It shapes the landscape. It has been here longer than you. It will be here after you are gone. And if the animists were right, if the early humans who treated rivers and mountains and wind as alive were not confused but seeing clearly, then maybe the appropriate response is not to dismiss them as primitive. Maybe the appropriate response is to remember what they knew. That the world is not a collection of dead things you can use and discard. It is alive, all of it, in ways that matter. And the way you treat it matters because you are part of it. There is no outside, there is no away. When you pollute the river, you pollute yourself. When you destroy the forest, you destroy part of the network you are embedded in. When you treat the world as a resource to be exploited, you are cutting off pieces of your own body and selling them for profit. That is not sustainable. It is not even sane. But it is what materialism allows. If the universe is dead, if consciousness is rare and exclusive, then most of the world is just stuff. And stuff has no value except what we assign to it. But if the universe is alive, if consciousness is woven into everything, then the world has intrinsic value. It matters in itself, not just because it is useful to us. And that changes the ethics, not in small ways, in the biggest way possible. There is also the question of meaning. Most people at some point ask what the point is. Why are we here? What is the purpose of life? And materialism, for all its successes, does not give you a good answer. If the universe is just particles following laws, if consciousness is just a byproduct of evolution, then there is no purpose, no cosmic plan, no reason you were born. You exist because a long chain of accidents happened to produce you. You will die because entropy increases and systems break down. And in between, you do whatever you want because nothing matters beyond what you decide matters. That is existentialism. It is honest. It is brave in a way. But it is cold, and a lot of people cannot live with it. They need meaning. They need to feel like their life is part of something larger. Materialism does not give them that. Religion used to. But for a lot of people, especially in the West, religion stopped working. The old stories do not fit the world we see. The old rules do not make sense. And so we are left in a strange place. We have the tools of science, but not the comfort of purpose. We know how things work, but not why they work. We understand the mechanics, but we have lost the meaning. And that gap, that absence, is one of the defining features of modernity. The sense that we are alone, that the universe is indifferent, that whatever we do, however hard we try, it will all end in heat death and none of it will have mattered. But if the universe is conscious, if we are the universe waking up, then meaning is not something we have to invent. It is something we discover. You are not here by accident. You are here because the cosmos, over billions of years, organized itself into a structure complex enough to reflect on its own existence. And you are that reflection. You are the part of the universe that knows it is here. That is your purpose, not to accumulate wealth or status or achievements, not to be happy or successful or remembered, but to be aware, to pay attention, to see the world clearly and recognize that you are not separate from it. Every moment of consciousness, every time you notice the light on the water, or the sound of wind in the trees, or the way another person looks at you when they think you are not paying attention, that is the universe noticing itself. That is what you are for, not to do something grand, just to be awake, to witness. And the witnessing itself is the meaning. Because without you, without minds like yours, the universe would exist, but it would not know it exists. Stars would burn, and galaxies would turn, and the whole vast machinery would keep running, but there would be no one home, no interior, no experience. You are the experience. You are the part that feels and that matters, not because someone is keeping score, but because consciousness is the only thing that makes existence more than just mechanics. You are the why underneath the how. And that is not nothing, that is everything. There is also terror in this, not just comfort. If the universe is conscious, if the boundary between you and it is thinner than you thought, then you are not as protected as you believed. The illusion of separation, the feeling that you are a self sealed off inside a body, is what allows you to function. It is what lets you make decisions, form relationships, care about some things and not others. If you lose that illusion completely, if the boundaries dissolve too far, you risk losing yourself. Not in the mystical sense, in the clinical sense. Psychosis is what happens when the self fails to hold itself together, when the distinction between inside and outside collapses, when thoughts that should feel like yours feel like they are coming from somewhere else, when the world stops making sense because the categories you use to organize it stop working. Mystics talk about ego death as enlightenment, and maybe it is, for some people, in some contexts. But it is also terrifying. The feeling of dissolving into everything is not always blissful. Sometimes it is annihilation, the loss of everything you thought you were. And if the universe really is conscious, if the separation really is an illusion, then what keeps you from dissolving completely? What holds the self together when the truth is that there is no self? The answer traditions like Hinduism give is practice, meditation, ritual, community, the structures that let you approach the truth gradually without being destroyed by it. You do not jump from ignorance to enlightenment in one step. You take small steps. You loosen the grip of the ego slowly. You learn to see the boundaries as flexible rather than fixed. And over time, maybe over many lifetimes, if you believe in that, you get closer to the realization that you are not separate without losing the ability to function as if you are. Because the paradox is that you need the illusion to live. You cannot drive a car or hold a job or love another person if you are constantly dissolved into cosmic unity. The self is a tool, a useful fiction. And the goal is not to destroy it, but to see through it, to know that it is a construct while still using it. That balance between knowing the truth and living the illusion is what wisdom looks like in this framework. It is not easy. It is not something you achieve once and keep forever. It is a practice, a dance. You step toward the truth, you step back toward the world, and you keep moving between them. And that movement, that oscillation, is the only way to hold both at once. There is also the question of whether any of this is true. And the honest answer, the one we gave in the last chapter, is that we do not know. We cannot know. The universe might be conscious, it might not. The evidence does not decide, the tools do not reach. And so what you believe, what you take seriously, is a choice, not a blind choice. You can weigh the arguments. You can look at the structure of the cosmos and the fact that consciousness exists and the way the old traditions and the new physics are starting to sound like each other. and you can decide whether that points towards something real or whether it is just pattern recognition running wild. But at the end of the day, the choice is yours, and the choice matters. Not because it changes what is true, but because it changes how you live. If you believe the universe is dead, you live one way. If you believe it is alive, you live another. The first way is not wrong. It has given us extraordinary things, but it is narrow. It cuts off possibilities. It treats consciousness as rare and matter as cheap, and the world as something separate from you. The second way is wider. It lets you see connections. It treats the world as alive and consciousness as fundamental, and the boundary between you and everything else as negotiable. Neither way is provable, but one of them feels true. And for a lot of people, the one that feels true is the one that says we are not alone, that the universe is not indifferent, that awareness is woven into the fabric of everything, and we are part of that weaving. So where does that leave us? We have been climbing this ladder for 8 chapters. We started with a photograph, a brain and a map of the universe that looked the same, and we asked whether the resemblance was an accident or a clue. We walked through the fine-tuning, the constants balanced so precisely that one part in a trillion either way would have made complexity impossible. We explored panpsychism, the idea that consciousness is not something brains produce, but something they access. We looked at the cosmic web and asked whether 2 trillion galaxies connected by filaments might be doing something that looks like thinking. We considered the possibility that we are not separate minds, but the universe waking up to itself through us. We stepped outside our universe and asked whether it might be part of something larger. A multiverse where entire universes play the role neurons play in brains. And then we stopped and admitted that we do not know. We might never know. The question is too big. The tools are too small. The boundary between science and metaphysics is too wide to cross, but the question is still worth asking. Because the act of asking changes something. It changes how you see yourself, how you see others, how you move through the world, and that change, the shift in perspective that happens when you take the possibility seriously, is not speculative. It is real. It is happening right now. If the universe is conscious, if we are thoughts inside a larger mind, then you are not what you thought you were. You are not a separate thing. You are a process, a temporary localization of awareness in a cosmos that has been aware since the beginning. You were never born. You are always here, and you will never die. You will just stop being here in this particular form. The pattern will dissolve, but the substrate will remain. And that substrate, that underlying consciousness, is what you actually are, not the body. Not the memories, not the personality, the thing underneath, the thing that has been watching the whole time, the awareness that is reading these words right now, that is not yours, that is the universe, looking at itself through you for a moment. Before the moment passes and the perspective shifts and some other part of the cosmos wakes up and asks the same questions you are asking, and the process continues forever or until it stops, and maybe even then, maybe even after the last star burns out and the last black hole evaporates and the universe goes dark, maybe even then the awareness remains, waiting, dreaming, preparing to wake again. We do not know, but the possibility is there. And the possibility is enough. It means we are not alone. It means the universe is not empty. It means that somewhere, in the structure of reality, in the connections between galaxies and the firing of neurons and the space between thoughts, there is something that knows, something that watches, something that cares maybe, or at least pays attention, and we are part of that. Not separate from it, not outside looking in, inside, always inside, looking out through eyes that are not ours, because nothing is ours. Everything is the universe. experiencing itself, one moment at a time, one life at a time, one thought at a time. And this thought, the one happening right now, the one asking whether the cosmos is awake, that is the universe asking, through you, about itself. And maybe, just maybe, beginning to understand. So here we are, at the end of the ladder, or maybe just the end of the part we can see. We started with a photograph, a slice of brain tissue next to a map of the cosmos, two images that should not have looked alike but did, and from there we climbed. Through fine-tuning, so precise it makes coincidence feel like a lazy explanation. Through panpsychism, the idea that consciousness is not something rare but something fundamental. Through the cosmic web, 2 trillion galaxies wired together in ways that make neural networks look like rough drafts. Through the possibility that we are not separate minds observing the universe, but the universe observing itself. Through multiverses stacked so deep that infinity becomes plural. And then through the hard truth that none of this is provable, that the tools do not reach, that the boundary between what we know and what we imagine is wider than the space between galaxies. And yet the question remains, stubbornly, uncomfortably, refusing to be dismissed. If the universe is conscious, you will never prove it, but you will never disprove it either. And in that gap, in that space where science stops and something else begins, you get to choose what you believe. Not blindly, not without reason, but carefully, knowing that the choice shapes everything, how you see yourself, how you treat others, how you move through a world that might be watching. The universe does not need you to understand it. It has been running for 14 billion years without your input, and it will keep running long after you are gone. But you need to understand it, because understanding is what you are. You are the part of the cosmos that wakes up and asks why. And whether the asking ever gets answered, whether the universe ever speaks back, the asking itself is the point. You are not separate from this. You are not outside looking in. You are the question. And maybe, just maybe, you are the answer too.